Yeah, hi everyone, welcome to PrepFusion. So in this video, we are going to study about probability distributions. So mainly we are going to study about binomial distribution, Poisson's distribution and exponential distribution. Till now what we have studied? Till now sir, we have studied about basics of probability, that how to solve the questions related to probability. Then we studied about random variable, we studied about different kind of random variables, right? Continuous random variable, discrete random variable, one dimension random variable, two dimension random variable, and even three dimension random variable. Then we saw central limit theorem and other miscellaneous topics also we have seen. Along with that, we studied about different kind of random variable. We studied about different kind of distributions like Gaussian distribution, uniform distribution. So all those distribution we have seen, and we have solved the question as well. Now some more distributions are there: binomial, Poisson's, and exponential. So these three distribution we will see, and we will solve questions related to them. Now let's forget about all these topics. This question is coming in your examination hall. Will you be able to solve this question? Let's just say this question is coming in your examination hall. You don't know what is binomial, you don't know what is Poisson's, you don't know what is exponential. This simple question is coming. Will you be able to solve this question? Absolutely, sir. These kind of questions we have already solved. That there is a factory which will manufacture electronic chips. Each chip has 5% of chance being defective. That means what is the probability of being defective? Probability of being defective is 5 by 100. So what is the probability of being non-defective? The probability of being non-defective will be 95 by 100. Right? If 10 chips are selected at random, then what is the probability that exactly 3 of them are defective? Exactly 3 of them are defective. That means, sir, we can take one case, defective, 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 and rest all I want to be non-defective. That means 7 of them I want to be non-defective, and rest of them I want to be defective. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 chips I am selecting. First one was defective, second was defective, third was defective, and next 7 of them was not defective. But sir, this is only one case. How many total cases are possible? Sir, how many total cases will be possible? Sir, if all 10 of them were different, then sir, it would have been 10 factorial. But sir, 3 of them are same and 7 of them are same. So I just need to find out the probability of this case, and then I need to multiply with 10 factorial divided by 3 factorial divided by 7 factorial. So this is what I need to do. So probability of being defective, that will be 5 by 100. So 5 by 100 will be multiplied 3 times. So 5 by 100 to the power 3. Multiply with 95 by 100, that will be multiplied with 7 times. 95 by 100, it will be multiplied 7 times. Multiply with 10 factorial, 3 factorial divided by 7 factorial. This is your answer. Is that understandable to you or not? Yes sir, this is the answer. This answer you would have seen. So this is how I will solve this question in the examination. Now can I write down this answer in a different way? Can I write down this answer in this way? 5 by 100 to the power 3 multiply with 95 by 100 to the power 7. Can I write down this particular thing as tan C3? Isn't it tan C3? Isn't it tan C3 only? What is the meaning of tan C3? Sir, tan C3. What is the meaning of NCR? What is the meaning of NCR? N factorial, n minus r factorial, r factorial. This is the meaning of NCR, right? I am not talking about Delhi. NCR. N factorial divided by n minus r factorial multiplied with r factorial. This is the meaning of NCR. So similarly, tan CR would be 10 factorial divided by 10 minus 3, that would be 7 factorial multiplied with 3 factorial. So this is the answer that you are getting. So now I am solving the same question with another method. Method 2. What I am doing? Now I am defining a random variable x. What is this random variable x? What you are supposed to find out? You are supposed to find out the probability that exactly 3 of them are defective. Exactly 3 of them are defective. Probability that exactly 3 of them are defective. So I am defining a random variable x, which is number of defective chips. Number of defective chips. This is the random variable that I am defining. So what you are supposed to find out? You are supposed to find out probability such that x is, your random variable x is taking value 3. This is what you are supposed to find out. Say yes or no. Do you agree to this point or not? That sir, I am supposed to find out this particular thing. That my random variable x is taking value 3. Just 1 second. Yeah, sorry for the interruption. A call came in between. So what we are supposed to find out? We are supposed to find out the probability of random variable x taking value 3. This is what we are supposed to find out. Understandable? Right? Now what I am defining? I am defining a probability p. I am defining probability p. how I am defining it. Sir, why you are defining all those things? You will be able to understand. Just have some patience. So I am defining a probability P, which is equals to getting a defective chip. Getting a defective chip. Getting a defective chip. So that would be equals to 5 by 100. Now I am defining a probability Q, which will be not getting a defective chip. Not getting a defective chip. Not getting a defective chip. That means you are getting a non-defective chip. That would be 95 by 100. And now I am defining another thing, which will be N will be equals to number of trials, or you can say number of chips selected. Number of chips selected. So how many chips are you selecting? That is equals to 10. So probability of random variable x taking value 3 would be equals to, out of 10 you are selecting 3 chips. Out of 10 you are selecting 3 chips which are defective. 3 chips which are defective and 7 chips which are non-defective. So this is the answer that you are getting. Is that understandable to you? Out of 10 you are selecting 3 chips which are defective and rest of them, which are 7, which are non-defective. So this probability of x equals to 3 could be written as probability of x equals to r. R is, what is r here? R is number of desirable cases. R is number of desirable cases. In place of desirable cases, I will write down something else that I will let you know what I will write down. What is P? P is getting a defective chip. That means P is the probability of success. P is probability of getting a defective chip. Okay, better I should write down P is probability of getting a defective chip. Probability of getting a defective chip. And what is Q? Q is the probability of not getting a defective chip. Probability of not getting a defective chip. So what is P? Probability of success. For you, what is the success? Success is that you get a defective chip, because what is your random variable x? Random variable x is saying that you need to get a defective chip. So for you, what is success? For you, the success is getting a defective chip. So P is the probability of success and Q is the probability of failure. Probability of failure. So what is R? Number of times success achieved. Say yes or no. And what is N? N is the number of trials. N is the number of trials. So in the whole scenario, when you are saying that probability of x equals to 3, what you are saying? You are saying that probability of from the 10 trials, from the 10 trials, how many trials are there? 10 trials are there. That means you are selecting 10 chips. Out of those 10 chips, you need success in 3. Out of those 10 chips, you need success in 3. So this is the meaning of probability of x equals to 3. Or if I say probability of x equals to r, what this would represent? This would represent from n trials, from n trials, probability of achieving r time success. This will be the probability of x equals to r. So probability of x equals to r is given by, out of n trials you need to achieve the success in r times. Multiply with probability of r, multiply with q n minus r. Isn't it the same thing that we are doing? 10c3 p to the power r q n minus r. So what this is representing? This is representing the PMF of random variable x. PMF of random variable x. And now this random variable x is known as binomial random variable, or you can say that x follows binomial distribution. X follows binomial distribution. So what all are the conditions of binomial distribution? So the first condition is that there could be only two scenarios. Either you get a success or you get a failure. First condition, either you get a success or you get a failure, and what you could understand that P plus Q will be equals to 1, because P is the probability of getting a success, Q is the probability of getting a failure. So P plus Q will be equals to 1. So in the binomial distribution, the first condition is that you either get a success or you get a failure. Second condition, that getting a success or getting a failure, they are independent of each other. Basically, every trial is independent of each other. That means initially if I am getting a defective piece, the next piece will be defective or not. Does that depend on the previous case? What I mean to say is that, sir, in the second row, let's just say there are a lot of chips. First chip I have drawn, that came out to be defective. Now the second chip that I will be drawing, will that depend on the previous chip? If the previous chip is defective, can I say the next chip will be defective or non-defective? No. Are you able to understand this point? So drawing the first defective chip, what is the probability? 5 by 100. Drawing the second defective chip, what is the probability? 5 by 100. Drawing the third defective chip, what is the probability? 5 by 100. But if I say I am having 52 cards, okay, and I am drawing the cards without replacement. So what will be the probability of drawing first king? So that will be 4 by 52. What will be the probability of drawing the second king? The probability of drawing the second king would be that, sir, now you are left with only 51 cards. Out of them, only 3 are the kings. So this probability is differing from this, no? Are you able to understand this point? The second probability is depending on the first probability, no? Because in the first one, you are drawing a king only. So second one is depending on the first one, because you are doing without replacement. You are taking one card, then another card you are taking. But here probability of taking defective case, 5 by 100. Probability of taking the defective case, again 5 by 100, again 5 by 100. So then only you can apply the binomial distribution. So what was the first condition? That says there could be only 2 chances, success or failure. Success plus failure, probability would be equals to 1. The second condition is that they should be independent. Every trial should be independent. And the number of trials, here what is the number of trials? This number of trials are 10, no? So this should be a finite number. The number of trials are 10. It could be 10, it could be 20, it could be 100, it could be 300, it could be 500, it could be 5 lakh, it could be 10 lakhs, but it should be a finite number. These are the conditions of binomial distribution. Sir, why would I remember all these conditions? No need to remember all these conditions. Sir, if this question was coming in my examination hall, will I be thinking that probability of success, probability of failure, P plus Q equals to 1, independent, number of trials, will I be thinking all these things? Absolutely not. I will be solving the question in this manner. So the bottom line is that I will solve no questions using binomial distribution. No question of probability, no question of probability should be solved using binomial distribution. So will I use binomial distribution in the examination hall for solving a question of probability? Absolutely not. Why is that so? Because, sir, in the basics, we have studied these kind of questions without the binomial probability. There I don't need to think too much that can I apply binomial, will my random variable x follow the binomial distribution or not. First of all, you need to define the random variable. Then you need to think whether it will follow or not. Then you will have to understand all the conditions. First, what you will understand, the sir, are there only 2 cases, probability of success and failure? First one is checked. Then you would see P plus Q equals to 1. Yes. Then you would see number of trials. Are they finite? Yes. Then you would see what you would see that if each trial is independent or not. So yes, if all 4 are checks, then you will apply the formula P x equals to R NCR P to the power R Q to the power n minus R. Then you will apply the formula and you will get the answer. There could be some chances that you might be thinking that all the events are independent, but some events might be dependent, right? So it will work for only independent cases. But for each trial, you will have to check whether they are dependent or not, whether they are independent or dependent. So it will be a hectic process. So, sir, we will never solve any question with the concept of binomial distribution. You would see in PYQs, a lot of questions are there which will be solved with the concept of binomial distribution. But rather than that, we will solve in this manner. That, sir, take one case, then just see how many cases are possible, job done. Have we solved these kind of questions previously? Absolutely, yes. Certainly we have solved. So all these things are we going to do in the examination hall? No. But since it is there in the syllabus, I need to teach binomial distribution. That's why I am teaching it. So what is the meaning of binomial distributions? That, sir, you are defining a random variable x which is following the binomial distribution. How it will follow? Whatever the random variable x you have defined, just write down that particular random variable. Then Probability of success, probability of failure, probability of success plus failure equals to 1. All the trials should be independent, number of trials should be finite. This is known as binomial distribution. So what do you mean by binomial distribution? Binomial distribution is a probability distribution that tells us the probability of getting a certain number of success in a fixed number of independent trials. Fixed number of independent trials. That means the trial should be independent. Along with that, the number of trials should also be fixed, where each trial has only two possible outcomes, either success or failure, and the probability of success remains the same in every trial. What does that mean? Probability of success remains the same in every trial. 5 by 100, 5 by 100, 5 by 100. This is the probability of failure. 95 by 100, 95 by 100, 95 by 100. This line simply tells that your next trial is not depending on the previous trial. That means all trials are independent of each other. Is that understandable to you or not? So probability of x equals to r. What does that mean? Probability of achieving success r times. Probability of achieving success r times in n independent trials. N independent trials. That is given by NCR p to the power r q to the power n minus r. This is your probability of x being equals to r. Will I be applying this formula everywhere? Absolutely not. I will not be applying this formula anywhere. But sir, why we are studying it? You will slowly understand why we are studying it. Let's just say this question is coming in the examination hall. What is your answer? Now I am just telling you that why we are studying this formula. Okay. So if this question is coming in your examination hall, just think about it. No probability, nothing. Just think about it. What is the scenario? That a team has 60% probability of winning a game. If the team is playing 5 independent games, then tell me the number of games the team is expected to win. Don't apply any formula, nothing. Just think about it. A team can win 60%. Chances are there that you will win the game. 60% chances are there that you will be winning it. So out of 5 games, how many games they will be winning? Tell me. Expected number of wins. What will be the expected number of wins? Expected number of wins. That will be 5 multiplied with 60%. Say yes or no? That would be equal to 3 win. Say yes or no? What is 5 here? Number of games played. Number of games played. And what is 60 by 100? Probability of winning. If someone wanted to solve it, how he would have solved? That sir, they are asking the expected number of games the team is expected to win. So what he will do? Method 2. What he will do? He will assume a random variable x that is equals to number of games a team is winning. A team is winning. Right? This will be x would be equals to number of games a team is winning. What you are supposed to find out? Expected number of games a team is winning. This is what you are supposed to find out. Now, what all values your random variable x can take? What all values your random variable x can take? A team may win only 0 games. No game they are winning. A team may win only 1 game. That only 1 game they are winning. A team may win only 2 games. They may win only 3 games. They may win only 4 games. Or they are winning all 5 games. These are the possible values of random variable x. Your random variable x can take these values. Your random variable x can take these 5 values. Either the team is winning 0 game, or the team is winning 1 game, or 2 games, or 3 games, or 4 games, or 5 games. What is the probability of random variable x taking value 0? That means the team is winning 0 games. That means team is losing all the games. Losing all the games. They are losing all the games. So what is the probability of losing? So probability of losing is 40 by 100. That means probability of losing is 0.4. So what will be the answer? So 0.4 all the games they are losing. So 0.4 multiplied with 0.4 multiplied with 0.4 multiplied with 0.4 multiplied with 0.4. What is the probability that they are winning only 1 game? Let's just say they won the first game and they lost all of them. So first game they have won, but they lost all other games. Is this the probability correct? No. Why is that so? Because sir, this W can vary. So other cases also we need to take. Sir, if all 5 were different, then answer would have been 5 factorial. but sir 4 are same. So 5 factorial divided by 4 factorial. So multiply with 5. Why is that so? Because here I have assumed that they are winning the first game, losing next 4. It might happen that they are losing the first one, then they are winning, then they are losing the 3 games. In that manner, 5 more cases would be there. So multiply with 5. Next one, they are winning 2 games, but losing all of them. So winning 2 games and losing the other games. Is this the probability correct? Absolutely not. Why is that so? Why this probability is not correct? Because sir, you are saying that initial 2 they are losing, initial 2 they are winning and rest all they are losing, but they may vary as well. So if they would vary, all of them were different, then answer would have been 5 factorial, but sir 3 of them are same and 2 of them are same. So what would be the answer? 5 into 4 divided by 2. So if you solve this particular thing, you will get the answer here to be 10. Or what may happen, they are winning 3 games, they are winning initially 3 games, but losing rest all of them. So winning 3 games but losing rest all of them. Multiply with 5 factorial divided by 3 factorial 2 factorial. So multiply with 10. Or what may happen, that sir they are losing 4 games, they are winning 4 games and losing only 1 game. This may also happen. This may also happen. So 0.6 to the power 4 multiply with 0.4, and here 5 factorial divided by 4 factorial. So multiply with 5. So directly I am writing multiply with 5. Or what may happen, that they are winning all the 5 games. Or what may happen, they are winning all the 5 games. This may also happen. So probability will be 0.6 to the power 5. Now can you find out the expectation of x? Yes sir, expectation of x will come out to be 0 multiply with 0.4 to the power 5 plus 1 multiply with 0.6, 0.4 to the power 5 multiply with 5 plus 2 multiply with this and so on, plus 5 multiply with 0.6 to the power 5. So when you solve all these calculations, then eventually you will answer, your answer would be 3 only. So someone would solve in this manner, right? So here I have defined a random variable x and expectation of x I have find out. This is how someone would be solving it. Eventually answer he would be getting is 3. So eventually what answer he is getting? The answer he is getting is, let's just say number of games played is equal to the number of trials multiply with the probability of success. So this is your expectation of x. He is getting this answer, where n is the number of games played, which is equal to the number of trials. That out of 5 trials, you may get the success in 0 trials, or in 1 trial, or in 2 trial, or in 3 trial, or in 4 trials, or in 5 trials. There are only 2 possible outcomes. N is the number of trials. Here there are only 2 possible outcomes, that either you will be winning it or you will not be winning it. Either you will be winning or you will not be winning. Are every one of them is independent? Yes, all the independent games are there. They are all independent. That means your random variable x will surely follow the binomial distribution. Say yes or no. So x is following the binomial distribution. So if your random variable x is following the binomial distribution, then what will be the expectation of x? That will be n into p. So on this particular scenario, a lot of questions is asked. So what is the bottom line? The bottom line is that sir, if this is my binomial distribution, if x is following the binomial distribution, if my x is following the binomial distribution, your random variable x is following the binomial distribution, then sir, the expectation of x would be given by number of trials multiply with the probability of success. This will be the expectation. And what will be the variance? Sir, this derivation I am not giving you, but the variance will come out to be n into p into q. This you can do, you can take another example and you can find it out. So what will be the scenario? That sir, expectation, or you can call it average, expectation, or you can call it average, that is coming out to be n into p, and the variance is coming out to be n into p into q. So on this particular scenario, the question would be asked, what they would give, that random variable x is following the binomial distribution, the average is given by something, variance is given by something, then find out the value of n, p, q. These kind of questions they would be asking. So there you directly need to remember for a binomial distribution, what is my expectation or what is my average? That is n into p. And what is my variance? N into p into q. What will be the standard deviation? So standard deviation would be nothing but under root n into p into q. This will be your standard deviation, right? Understandable? What will be expectation of x square? Can you find out expectation of x square? Yes sir, expectation of x square minus expectation of x whole square would be equals to the variance only, no? So variance I already know that is npq. This I already know np whole square. So from here expectation of x square also I can find out. So everything I can find out. Just you need to remember only two things, that expectation of x is n into p, variance is n into p into q. If x is a random variable which is following the binomial distribution, then its average will be n into p and variance will be n into p into q. Based on this, a lot of questions will be asked. Is that understandable to you or not? Completely understandable, sir. Surely understandable. So all the analysis that we have done for binomial distribution, that is absolutely clear to you. That sir, if the question is coming on probability, will I use binomial distribution? Absolutely not. Right? I will solve by my basic concept. Whatever the question is given, I will read, I will make one cases, then I will get to know how many other cases are there and I will solve the question. I don't need to do all this process. All this process I did just to let you know the meaning of binomial distribution. That x is a random variable which might be following the binomial distribution. Condition would be that number of trials, all the number of trials should be finite and independent. There should be only two chances, probability of success, probability of failure. Probability of success in all the trials should be the same and they should be independent of each other. Probability of success plus probability of failure would be equals to 1. These all are the condition. Who would check all these conditions in the examination hall? That's why we will solve the question in this manner. But in the examination hall, if they are saying that your random variable x is following the binomial distribution, then you let us know what will be the what will be your average and what will be your variance. Then what you will do, n into p, or you can say n into p into q. How did we verify? We verified with a very simple example that sir, if team has a chances of winning 60%, then if they are playing 5 games, then how many games they are expected to win? So that would be the number of trials, the number of independent games they are playing, multiply with the probability of success. So 5 into 0.6, that will be 3 wins they will be getting. Or sir, I could define a random variable x that is equals to the number of games they are winning. This is what I can define. Like what you are supposed to find out? Find the expected number of games they are winning. Expected number of games the team is winning. The expected number of games the team is winning. That we are supposed to find out. So I assumed a random variable x which is the number of games a team is winning. That means I am supposed to find out expectation of x. This is what I am supposed to find out. That means x is a random variable which can take values 0, 1, 2, 3, 4, 5. X can take value 0, that means the team is winning 0 games, or they are winning 1 game, or they are winning 2 games, or they are winning 3 games, or 4 games, or 5 games. Understandable? So probability of x taking value 0, 1, 2, 3, 4, 5, that we are writing down, and then we are finding out the expectation, which is coming out to be 3 only. So x is following the binomial distribution? Absolutely. Why is that so? Because sir, there are only two chances, winning or not winning. Are they independent of each other? Absolutely yes. Are all the events independent of each other? Absolutely yes. That means yes, they are following the binomial distribution. So for a binomial distribution, the expectation of x is coming out to be n into p. What about the variance? So derivation I am not giving you, but that would come out to be n into p into q. Understandable? Let's solve some questions which would be asked in the examination. These kind of questions have been already asked, but this kind of question can also be asked. That I manufacture electronic component, a factory manufactures electronic components, each component has 20% chance of being defective if 15 components are selected randomly. If 15 components are selected randomly and independently, then determine the mean and variance of defective components, number of defective components. So what will be my random variable x? The number of defective components, number of defective components, number of defective components. So x can take either value 0. The number of defective components could be 0, it could be 1, it could be 2, it could be 3, or it could be till 15, right? Understandable? So what is n? What is my n? What is my n? N is the number of trials. That means how many defective components are you selecting? So value of n is 15, right? What is the probability of success? Probability of success means probability of finding a defective component. What is the probability of success? P is the probability of success, or you can say probability of getting a defective component, because this will be the success for me. What is my random variable x? Number of defective components. So probability of success would be finding a defective component. Let's see other example. What was my random variable x? Random variable x was number of games a team is winning. So what will be the probability of success? The probability of winning a game. What was the random variable x here? What was the random variable x here? Random variable x was number of defective chips. So what was the probability of success? Probability of getting a defective chip. Are you able to understand this point? So similarly, what is my random variable x here? What is my random variable x here? Number of defective components. So what will be my probability P? Probability of success. That means getting a defective component. Probability of getting a defective component. Probability of getting a defective component. Defective component. That will be my probability P. What that would be equals to? That would be equals to 0.2. So N you know, P you know. Is it following the binomial distribution? Sir, either you will get a defective component or you will get a not defective component. Are they independent of each other? Absolutely yes. P plus Q equals to 1? Yes. All 15 trials are independent? Yes. So it is surely following the binomial distribution. Binomial distribution. So what will be the expectation of x? Sir, expectation of x, or you can say mean, will be nothing but n into p. N into p. N into p. That means 15 into 0.2. That would be equals to 3. And what will be the variance? So variance or sigma x square you can say. So that would be n into p into q. So 15 into 0.2 into 0.8. Right? So that will be 2.4. Is that clear to you? So these are the answers, 3 and 2.4. One more thing you would see that always in the binomial distribution, always you would see that mean would be greater than the variance. Okay? Mean would be greater than the variance. Why is that so? Because what is mean? Mean is n into p. N into p. And what is variance? N into p multiply with q. That means variance is nothing but mean multiply with q. Now the value of q will be less than 1. So let's just say mean was 2. Value of q is less than 1. Let's just say it was 0.7. So what will be the value of variance? That will be 1.4. So mean was 2. Variance is coming out to be 1.4. So variance will always be lesser than the mean. So mean will always be greater than the variance. Okay. So in binomial distribution, mean will be greater than the variance. This could be asked in one line or in one mark. Which of the following statements are true? That in binomial distribution, mean is greater than the variance. These kind of questions could be asked in the examination. So you would be able to tell, yes, this statement is correct. Okay. Next question. A random variable x denotes the number of defective items in a sample and follows a binomial distribution if the mean of the distribution is 4.8. Mean of the distribution is 4.8. Mean is 4.8. And standard deviation is 1.386. What is given? Standard deviation is given. Standard deviation is given, which is 1.386. So what will be the variance? Variance will be square of this. Variance will be square of this. So what will be the answer? 1.386 whole square. 1.386 whole square. 1.92. So it will be n into p into q, which will be 1.92. Right? So you know the value of np. You know the value of npq. What is the value of np? Np is 4.8. 4.8 multiply with q equals to 1.92. So what will be the value of q? 1.92 divided by 4.8. So value of q is coming out to be 0.4. Right? Value of q is coming out to be 0.4. So what is the value of p? Value of p will be 1 minus 0.4. So value of p will come out to be 0.6. Right? And if the value of p and everything we know, then n into p is 0.6, that is equals to 4.8. So n is coming out to be 8. Value of n is 8, value of p is 0.6, and value of q is 0.4. So n into p is given, n into p into q is given, which is 1.92. From here I put the value 1.98 divided by 4.8, that will be 0.4. Value of p is 0.6, and there you go. This is the answer. Very simple concept, and these kind of questions are very famous in the examination hall. I don't know why they ask these kind of questions again and again. If they are asking some question from binomial distribution, then this is the first question they will be framing. Or they can frame the question based on probability, but based on the probability, we will solve in this manner. Right? Right? Let's just say next question is coming, this question is coming. So you need to solve this particular question. A coin has a probability of 0.6 of landing heads on each toss. This is a unbiased. This is a biased coin, right? It is a biased coin. Why it is biased? because probability of 0.6 of landing head, that means probability of getting a head is 0.6, right? X denotes the number of heads obtained. A random variable x denotes the number of heads obtained. Number of heads obtained, right? In 10 coin tosses. So what all values x can take? X can either take value 0 or 1 or 2 or 3 or whatever it is. Now what you are doing, you are tossing the coin 10 times. You are tossing the coin 10 times. Either you will get a head or you will get a tail. So either you will get head or not head, right? Are all the tries independent? Absolutely, sir. All the trials are independent. All the trials are independent. Probability of getting a head, that means probability of x is number of heads obtained. That means what will be the probability of success? Probability of success will be equals to probability of getting a head, probability of getting a head, and that would be equals to what? Probability of getting a head, that would be equals to 0.6. So what will be the probability of failure? That would be 1 minus 0.6, that would be equals to 0.4. Understandable? Say yes or no. Is this clear to you? Now let me know, p plus q equals to 1. Yes, p plus q equals to 1. Probability of getting a head, probability of not getting head, are they independent of each other? Yes, they are independent of each other. All the trials are finite? Yes, trials are finite. All of them are independent of each other? Yes, they are independent of each other. What does that mean? That means x will follow the binomial distribution. Binomial distribution. And if x is following the binomial distribution, we can apply the formula of binomial distribution only. So what we are supposed to find out? We are supposed to find out the probability of x plus 2 whole square. This is what we are supposed to find out, right? So what we will do, if I open it up, a square plus b square plus 2ab, a square plus b square plus 2ab. This is how I can open it up. So if I open it more, it could be written as expectation of x square plus 4 into expectation of x plus expectation of 4. So expectation of 4 could be written as 4 only. All these things we have seen in the random variables, right? Now what will be expectation of x square? So you let me know what will be expectation of x. Sir, expectation of x will be nothing but n into p. Number of tiles are 10. What is the value of n? What is the value of p? That is 6. So expectation of x is 6. This is the answer that you are getting. Now what is variance? Variance is n into p into q. That would be 10 into 0.6 into 0.4. 10 into 0.6 into 0.4. That would be 2.4. So this would be 2.4. So variance would be expectation of x square minus expectation of x whole square, that would be equals to 2.4. So expectation of x square would be equals to 6 square will be 36. Here you put expectation of x, no, that is 6. 6 square will be 36, 2.4. So from here expectation of x square is coming out to be 38.4. Expectation of x square is coming out to be, do we have the page? Yes, we have the page, you know. तो इतना टाइम वेस्ट क्यों कर रहा हूँ यहाँ पे? So that would be 38.4, right? 36 plus 2, so 2.4, that would be 38.4. So what is the answer we are getting? Expectation of x square is 38.4 plus 4 into expectation of x, that is coming out to be 6. इसको यहाँ plus 4. So 24 plus 4, 28. 28 plus 38.4. 38.4 plus 28. So answer is coming out to be 66.4. Answer is 66.4. So this is the answer that you are getting. 66.4. That's the answer. So these kind of questions should be solved. Okay. There is no problem in the examination for solving these kind of problems. Just when you read probability of getting head, then probability of getting tail, they will be independent events. P plus q will be equals to 1. Number of trials are 10. Then they are asking about the expectation over variance. So I know the formula of expectation, I know the formula of variance as well. Using those formulas, I can find out the expectation of x square, I can find out the expectation of x, and then I can simply solve it. So this kind of question should be solved. There is nothing in this question. X square plus 4 plus 4x, simply take it out. Expectation of x square, from here we got 38.4. How we got it? What was given? Sir, variance I knew, it would be n into p into q. So sir, I could find out the variance. From there I could get the value of expectation of x square, right? then I simply put it, I get the answer. Let's go to the next one. Try solving this question on your own. Okay, it is a good question, but try solving it on your own. You will be able to solve. There are 800 families. Each family is having 4 children. 800 families are there. Each family is having 4 children. That means one family will have 4 children. One family will have 4 children. Each will have 4 children. Or I am saying 4 kids. They are having 4 kids. Assuming the probability of having a boy and a girl or a girl is equal, and that the gender of each child is independent of others. That means what is the probability of having a boy? Probability of having a boy is 1 by 2. Probability of having a girl is also 1 by 2, and they are independent of each other. How many families would you expect to have exactly 2 boys? Either 2 boys or 3 girls, all girls. 3 questions we are asking. What is the first question? First of all, what we are asking? Would you expect to have? That means they are asking the expectation. So for finding the expectation, first we need to find out the probability. So first what we are finding out? We are finding out the probability. What we are finding out? We are finding out the probability of one family having exactly 2 boys. This is the probability we are finding for one family. What is the chances that one family will be having exactly 2 boys? What are the chances? How many odds are there? How many chances are there that one family will be having exactly 2 boys? So they are having 4 kids, no? So it might happen that, sir, first 2 were boys and next 2 were girls. But sir, this is the only one case that you have made. If all 4 were them different, then I would have done 4 factorial divided by 2 factorial, because boys same, girls same. So this will be the answer. So probability of having a boy 1 by 2, probability of having a boy 1 by 2, probability of having a girl 1 by 2, probability of having a girl 1 by 2. Sir, only one case you have taken. There will be, sir, total would have been 4 factorial cases if they were different, but 2 of them are same. Next two of them are also same. So what is the answer you are getting? 6 divided by 16, 3 by 8. 3 by 8 is the answer we are getting. Because 4 factorial, 4 into 3, 12, 12 divided by 2 will be 6. 6 divided by 16, that would be 3 by 8. So 3 by 8 is the answer we are getting. 3 by 8 is the answer we are getting. That means what they are saying? That there are 3 by 8 or 300 by 8. What is 300 by 8? If I talk in terms of percentage, so 300 by 8 is 37.5. If I talk in terms of percentage, so what does that mean? That means I multiply with 100%. What is the answer I will get? 37.5%. So there are 37.5% chances that one family will be having exactly 2 boys. What I can say? There are 37.5% chances. There are 37.5% chances that one family will be having exactly 2 boys. Is that statement correct to you? Now what we are supposed to find out? We are supposed to find out that what is the expectation that out of 800 families, how many families would be having exactly 2 boys? What is the expectation? What you would do? I will simply multiply 3 by 8 with 800. So out of, can I say in this manner that, sir, for one family I have got the answer to be 3 by 8. So can I say in this manner, out of 8 families, there would be 3 families, they would be having exactly 2 boys. Can I say in this manner? From this 3 by 8, can I say one thing? What is 3 by 8? So 3 by 8 is the probability of one family having exactly 2 boys. One family having exactly 2 boys, that is 3 by 8. Understandable? So can I say that out of 8 families, it is expected that 3 families will have exactly 2 boys. Let's understand the meaning of expectation a bit more. Okay, what I do is that I add another page and let me tell you the meaning of expectation a bit more. Let's just say you roll 2 dices. Okay, you are rolling 2 dices. So what is the possible value of sum? You know that, sir, possible value of sum would be either 3 or 2 or 4 or 5 or 6, 7, 8, 9, 10, 11, 12. This is the possible value of sum. Now I am asking a question that I am rolling a dice. Okay, now I am rolling the dice. Now whatever the number that is appearing here, no, you add these numbers. So what is the expected value you will be getting? Someone would say that, sir, what if 1 appeared and here 3 appeared, sir, the value you are getting is 4. Someone would say that, sir, what if you get 2 here and 4 here, you may get the value 6. So in that manner, different answer could be possible. But what is the expectation? What is the expectation? The expectation would be the average of all of them. And the average would come out to be 7. How you can do is that you can take the, sir, least possible answer is 12, highest possible answer, least possible answer is 2, highest possible answer is 12, divided by 2, answer would come out to be 7. So expectation would be that you are getting the sum to be 7. And you do one thing, you take 2 dices, you roll them 100 times. Okay, you roll them 100 times, 100 times. What you do? You roll them 100 times. Do one thing, whatever the number that you are getting, add them up. Let's say first I got 4, 1 plus 3, 4, then I got 6, then it might happen that 5 plus 7, I got 12. Now do this thing, okay, do this thing, do it 100 times, do it 100 times, then find average of all of them, find average of all of them. I am telling you it will come near to 7 only. In my free time, traveling in a bus, I have done this experiment, okay, although I was doing it in the, our mobile dices. So what I was doing, I was rolling 2 dices, I did it 100 times, and you will notice this thing, that, sir, whatever the number I am getting, write down those numbers, get all the numbers, add them 100 times, and then take their average. It would come out to be nearly equals to 7 only. Someone would say, sir, it would depend on luck. Then it might happen that, sir, one guy is rolling it and he is getting 1, 1, 1, 1, 1, 1 again and again, sir. Every time he got the addition to be 2, sir, answer would come out to be 2. Yes, it may happen. No, but there are very less chances of this. There is very less probability of this. That 1 by 36 cases are there that you will get this case. Then again 1 by 36 cases, then again 1 by 36 cases. So 1 by 36 to the power 100. This is the probability that every time he will be getting 1, 1 only. This is the probability. 1 by 36 to the power 100 is the probability that every time he will be getting 1, 1, 1, 1, 1, 1, 1, 1 only, because he is doing it 100 times. So 1 by 36 to the power 100, which is a very less probability. So very less chances are there that every time he will be getting 1, 1, 1, 1, 1, 1. Hypothetically, you can say that, sir, what if someone is getting 1, 1, 1, 1, 1, 1, 1 only? So his average would be 2 only. But you do this thing in the mobile dices, because there would be random experiments. No, that would be completely random. So random experiment would be there, you do it, and then you would see that average is coming out to be nearly 7 only. Or you ask ChatGPT to do it. You ask ChatGPT that you do one thing, you roll 2 dices 100 times. Add the number on them, take their average, let me know what is the answer you are getting. ChatGPT will also say nearly 7 only. Nearly 7. So this is what expectation is known as. Okay. So let me ask you one more question, that if I am tossing a coin, let me know what is the expected number of trials such that you will get a head. I am tossing a coin, let me know expected number of trials such that you are getting a head. That means expectation of a number of trials such that you get a head. So some people will be solving in this manner, that, sir, I will assume a random variable x, which is equals to the number of trials to get a head, trials to get a head. So sir, x can take value 1, 2, 3, 4 and so on. Then I will find out their corresponding probabilities. So sir, in the first chance only I am getting a head, that probability will be 1 by 2. So in the second chance I am getting a head, that means in the first time I got tail, and second time I got a head. Or sir, for 3, first time I got tail, second time also I got tail, then I got head. So eventually, sir, this is what I will do. Expectation of x will come out to be 1 into 1 by 2, that would be 1 by 2, plus 2 into 1 by 2 to the power 2, plus 3 into 1 by 2 to the power 1 by 2 to the power 3, and so on. When you solve this particular thing, expectation of x will come out to be 2. Okay. When you solve this addition, it will come out to be 2. That means it is expected that you toss a coin 2 times. It is expected that you toss a coin 2 times and you will get head 1 time. Basically, what he is saying, that if you toss a coin 1 time, you will get a tail. Then in the next, since you have already got a tail, no, so in the next, the chances are there that you will be getting a head. because they are having the equal probability. No, this is also having a probability of 1 by 2 and this is also having a probability of 1 by 2. So they are saying that if you are tossing it 2 times, no, then there are chances that you will be getting ahead. If I ask you that I am rolling a dice, let me know how many times I will have to roll the dice. What is the expected number of rolling I have to do such that I get the number 5? I'm asking you one question, that let me know the number of times I will have to roll. Let me know the expected number of times I will have to roll the dice such that I get the number 5. What will be the answer? You can solve it, the answer will come out to be 6. That means they are saying that when you roll a dice, either you can get a 1 or 2 or 3 or 5 or 6, all with the equal probabilities. All of them you will get with the probability of 1 by 6, 1 by 6, 1 by 6. That means they are saying that if you roll the dice 6 times, then there are chances that one time you will be getting 1, other time you will be getting 2, or you will be getting 3, 4, 5, 6. That means in 6 trials, you will surely get 1 times 5. This is the expectation that they are having. So this is the meaning of expectation. Are you able to understand this point? What is expectation standing for? First example we took, what is the addition of sum? What is the sum of the number that is appearing on the dice? Sir, sum could be either 2 or 3 or 4 or 5, 6, 7, 8, 9, 10, 11, 12. What is the probability of this occurring? That will be 1 by 36, right? You know, this will be 2 by 36, this will be 3 by 36, this will be, so all of them are not occurring with the same probability. Let's just say if all of them were occurring with the same probability, then what would have been the answer? That you are getting the sum equals to 10. What would have been the answer if all of them were occurring with the same probability? So I'm asking, what is the expected number of trials I will have to do such that I get the sum equals to 10? So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. So answer would have been 11. Although this is a senseless question, but here what I'm asking, that when you roll 2 dice, what is the number of sum? What is the expected number of sum that you will be getting? What is the expected sum that you will be getting? So that expected sum would be 2 plus 12 divided by 2. The expected sum would be 7. Okay. Then second example we saw about the tossing of a coin. That what is the expected number of trials I will have to do to get ahead? That would be 2. And third example we saw regarding the dice, that if I am rolling the dice 6 times, then there are chances that I will be surely getting number 5 at least once. Okay, so this is the meaning of expectation. All this discussion I did because it will help you solve the question in a much quicker manner. Let's just say this question is coming in the examination hall, and this question has actually come as well. That find the expected number of sum on the dice. That you are rolling 2 dice, find the expected number of sum. What will be the expected sum here? So expected sum would be 7. This was the answer. But a lot of people solve in this manner. That sir, the sum random variable x, they assumed that the sum could be what will be the random variable x? The random variable x they assumed as the sum on the both of the dice. Then they made that sir, sum could be either 2 or 3 or 4 or 5 or 6. Then they wrote down the corresponding probabilities. This will be 1 by 36, this will be 2 by 36, and then they multiplied 2 multiplied with 1 by 36 plus 3 multiplied with 2 by 36 plus 4 multiplied with 3 by 36. In that manner they multiplied, and then eventually they got the answer to be 7. But if someone is conceptually very sound, if he knows the meaning of expectation, what he would do? That sir, if I am rolling the dice, either I will get 2 or 3 or 4 or 5 or 6, minimum number 2, sir, maximum number 12, 12 plus 2 divided by 2. So average I need to take, average would be 7 only. That's it. So average of 2 plus 12, that is 7. Average of 3 plus 11, that is 7. Average of 4 plus 10, that is also 7. Average of 5 plus 9, that is also 7. Average of 6 plus 8, that is also 7. And average of 7 is 7 only. So eventually you add all these numbers divided by the number of times, you will get the answer to be 7 only. You will get the answer to be 7 only. Okay, so average will be 7 only. Understandable? So this is the meaning of expectation. So I just wanted to let you know the meaning of expectation. I will remove all those things. So all this discussion I did just to let you know that here I can write down that if my probability of one family having exactly 2 boys, I am getting 3 by 8. Probability of getting a head is 1 by 2. So can I say that in 2 trials, I will be getting 1 head. In the expected 2 trials, I will be getting 1 head. So similarly, can I say the same thing? That in the expected that in the expected 8 trials, I will be getting 3 families. In the expected 8 families, I will be getting 3 families which will be having exactly 2 boys. In the expected, in 8 families, can I write down in this one, in this manner? In 8 families, 3 families are expected to have exactly 2 boys. So in 8 families, 3 families are expected. So in 800 families, how many families will be expected? So in 800 families, this multiplied with 100, so this will also be multiplied with 100. Out of 800 families, 300 families are expected. So this is the answer. This is the answer of first one. Or eventually, what was the answer? The answer of first one was, sir, the probability you got 3 by 8 multiply with 800. Answer is 300 families. So can you compare it with the example of rolling a dice? Yes, sir, I can compare it with the example of rolling a dice as well. That, sir, in the dice, what is the probability of getting a head? Sir, probability of getting a head is 1 by 2. That means if you roll the dice 2 times, no. If you roll the dice 2 times, then it is expected that you will be getting a head at least once. Right? So expected number of rolling the dice, or I should say tossing the dice. I should not say dice, it is coin. Sorry, it is coin. So expected number of tossing the coin such that you get a head, that will be 2. So similarly, probability of one family having exactly 2 boys, that is coming out to be 3 by 8. That means out of 8 families, 3 families are expected to have exactly 2 boys. So out of 8 families, 3 families are expected to have exactly 2 boys. So out of 800 families, there would be 300 families. What will be the answer of second? So for the answer of second, what I would do? Either 2 or 3 boys. Either 2 or 3 boys. So what I will find out? Probability of one family, probability of one family having either 2 or 3 boys. Right? Probability of one family having either 2 or 3 boys. So what all are the chances? Sir, either 2 or 3. This is what they are saying, no? Either 2 or 3. So the family can have either boy, boy, girl, girl, or boy, 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 girl. Right? Boy, boy, girl, girl, or boy, 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 girl. This is the scenario. Right? So here what will be the scenario? Multiply with 4 factorial, divided by 2 factorial, divided by 2 factorial. Multiply with 4 factorial, divided by 3 factorial. So these probabilities are 1 by 2, 1 by 2 to the power 4. Multiply with this, we have already seen, no? Multiply with 6. Or this kind of question you should be able to solve now. I should not be explaining this now, because this kind of question we have seen, no? Probability of a family having either 2 or 3 boys. If this question I am asking that each family is having 4 kids, find the probability that one family would be having either 2 or 3 boys. Will you be able to solve it? Yes, sir, either 2 boys or 3 boys. Understandable? Multiply with 4. So what is the answer you are getting? 6 by 16 plus 4 by 16. So answer will be 10 by 16, 5 by 8. So what will be the answer of second question? Sir, out of 8 families, 5 families are expected that either they will have 2 boys or 3 boys. So out of 800 families, sir, 500 families are expected that they will be having either 2 or 3 boys. So answer would be 500. Out of 8 families, 5 families are expected that they will be having either 2 or 3 boys. So out of 800, 500 families are expected that they will be having either 2 or 3 boys. Next question, all girls. Next question is all girls. Next question is all girls. So the chance would be girl, 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 girl. So what is the probability? Probability that one family is having all girls. This will show the probability that one family having all girls as their child, as their kids. So all 4 of them should be girls. So answer would be 1 by 2 to the power 4. So probability will be 1 by 16. Someone would say, sir, I can get 4 factorial, but all 4 are same. So 4 factorial divided by 4 factorial, that would be 1 only. Right? So probability will be 1 by 16. So out of 16 families, 1 family is expected to have all 4 girls. So what will be the answer? Out of 800 families, how many families are expected? Out of 800 families, 50 families are expected to have all girls as their children. So answer is 50 families. So whenever in the question it is asked to find the expect to have, then always our target would be that we will find out for one. Then we can generalize. The same thing that we did here as well in this question, that what is the expected number of games a team will be winning. So if they are playing one game, then there are chances that they will be winning 60% of the game. If they are playing one game, then probability of winning their game is 6 by 10. That means if they play 10 games, out of the 10 games they will be winning 6 games. So out of 5, how many games they will be winning? Out of 10, if they are winning 6, so out of 5 they will be winning 3. That's the answer. So similarly here as well, we will find for one family. Probability we will find out. So here we have find out the probability. So what this probability is representing, that out of 8 families, 3 families will be having exactly 2 boys. So out of 800 families, 300 families will be having exactly 2 boys. 300 families are expected to have exactly 2 boys. Then 500 families are expected to have exactly 2 or 3 boys. Then 50 families are expected to have all 4 girls. Is that understandable to you or not? So this is how we are going to solve these kind of problems. So always whenever in the examination they are asking some expectation, that what is the expectation that these many guys would be there, this particular thing would be having, then you find for one and then you generalize it. Is that understandable to you? So always if they are asking the expected number, then we will find the probability. Our concentration would be towards the probability. We will find the probability, then we will multiply that. What is our sample set? The set is 800 families. Our sample space is 800 families. We have find out for one. So multiply with 800, we will get the answer. Understandable? Is that clear to you? So this is the question that's a good question actually, and this is how we are supposed to solve. So these kind of question might be feeling like that, sir, what they mean to ask here, but in the examination we need to have patience. If they are asking the expected number, that means we will generalize it for one, we will find out the probability, and once we have got the probability, then we will find out the expected number. So always whenever they are asking expected number, expected to have, answer will be in the numbers, answer is in the numbers, 300, 50, 500. So if the answer is in numbers, then our focus will be towards finding the probability, and if we get the probability, after that we will be able to generalize. A lot of questions we are going to solve, and in all the questions we are going to follow the same process. Okay, this is the next question that we need to solve, and from here we will understand the meaning of Poisson's distribution. Okay, so you try solving this question. I need to take a call as well, so I will take a break, I will drink some water, and you try solving this question, and then I will come back. Okay, this is a very simple question. With the basic concept of a probability you will be able to solve, but from here we will understand the meaning of Poisson's distribution. Okay, so here you are taking 400 chips, here you are selecting 20 chips. 20 chips you are selecting, right? So you try solving this question, you will get the answer, and we will understand the meaning of Poisson's distribution from here. So let me take a break and then I will come back. Yeah, welcome back. So let's solve this question. A rare manufacturing defect occurs on an average 1 out of every 400 electron chips. 1 out of every 400 electron chips produced by the factory. What does that mean? Probability of manufacturing defect occurring. That is, probability of a manufacturing defect occurring is 1 by 400. Because 1 out of every 400 electronic chips produced by the factory. So out of 400 electronic chips, 1 will be defective. This is what they are saying. And now a quality inspector randomly selecting 20 chips from a large batch of for inspection, assuming that the quality of each chip is independent of others, find the probability that exactly one of the selected chip is defective. That means you are selecting 20 chips. Out of those 20 chips, you need only one to be defective. That means only one should be defective. Rest all of them should be non-defective. Rest all of them should be non-defective. Rest all of them should be non-defective. That means 19 of them should be non-defective. 19 chips should be non-defective and one should be defective. and one chip should be defective. Too many calls today. This is the scenario, right? So what is the probability of getting a defective chip? That is 1 by 400. And what is the probability of getting a non-defective chip? That is 399 by 400. So sir, this is one of the case. How many total cases would be there? Sir, there are total 20 factorial divided by 19 of them are same. So this probability you will see and multiply with 20. So first chip is defective, 1 by 400, and next 19 chips are non-defective. So 399 by 400, it will be multiplied 19 times. So to the power 19, right? Multiply with 20 factorial, because they could be changed 20 factorial times. So multiply with 20 factorial, but 19 of them are same. So divided by 19 factorial. So multiply with 20. This is the answer that you are getting. This is the answer of exactly one of the chips should be defective. This is the answer that you are getting. This is your answer. This is your answer. Now if you solve it, what answer you will get? So do one thing, you put this thing in your calculator and see the answer, what answer we are getting. So if we put this thing in the calculator, the answer will be 399 by 400 to the power 19 into 20 divided by 400. So answer is 0.0476. This is the answer. Let me do the calculation again. So 399 by 400 to the power 19, 0.0476. This is the answer. Although like this is a very large value, no? Not very large, I should not say very large value. I should say that calculation will be a bit large here. If you are doing it manually, 399 by 400, then you are multiplying 19 times. Manually a bit larger calculation. And sample space is 20 chips. 20 chips is a bit larger number, no? Your N is 20 here. The number of trials are 20. Out of those 20, you need only one chip to be defective, right? 20 trials are there. 20 trials are there. Out of those 20 trials, you need only one chip to be defective. Only one should be defective and 19 should be non-defective. All of them are independent? Absolutely yes. Probability of success, probability of failure, everything is clear. P plus Q equals to 1, all of them are independent, everything is crystal clear. What does that mean? That means this will follow the binomial distribution. Crystal clear means I mean to say that they are independent as well. P plus Q equals to 1 as well, and there are only two outcomes, success or failure. It will follow binomial distribution. Binomial distribution. Say yes or no. So it will follow binomial distribution for sure. So what does that mean? I could have solved in this manner as well. Probability of getting the success only one times. So out of 20, only one should be defective. Only one should be defective. And rest 19 should be non-defective. So this answer I could have also done. This could also be my answer. And what is my random variable x here? So how would you find out the random variable x? You read the question. Probability that exactly one of the selected chips is defective. So random variable x would be number of defective chips. Number of defective chips. This would have been the random variable x. So number of defective chips to be 1. Number of defective chips should be equals to 1. So answer would be 20C1, 1 by 400 to the power 1, 399 to the power 400 to the power 19. 399 divided by 400 to the power 19. You will get the same answer. Understandable? Now you see one more thing. When I did this calculation, probability of x equals to 1, e to the power minus lambda, lambda to the power 1 divided by 1 factorial. Sir, what you are doing here? What is lambda here? Lambda is nothing but n into p. What is n? You are selecting 20 chips, right? What is n? N is 20 chips. What is the probability of success? That is 1 by 400. What is the answer you are getting, sir? 1 by 20 I am getting. So when I did this calculation, e to the power minus 1 by 20 multiply with 1 by 20 to the power 1 divided by 1 factorial. When I did this calculation, I got the same answer. You can do it. 1 by 20, right? Plus minus e to the power divided by 20. You are getting the same answer, 0.0475. You are getting the same answer here. So sir, what was this? what you did here, you are getting the same answer, 0.0475, here as well 0.0476, nearly you are getting the same answer. So you are saying that probability of x taking value r, that is equals to e to the power minus lambda, lambda to the power r divided by r factorial, where lambda is nothing but n into p, which is nothing but expectation of random variable x. But sir, here you are saying that random variable x is following the binomial distribution. Here only you are saying that random variable x is following binomial distribution. Binomial distribution. Binomial distribution. Here you are saying that it is following binomial distribution. And sir, here you are defining the probability in some other way. Yes, x was following the binomial distribution. Absolutely yes. It is no doubt about it that it is following the binomial distribution. And if it is following the binomial distribution, what is the probability of x taking value r? So that would be nothing but NCR, probability of success to the power r, probability of failure to the power n minus r. This is surely correct. But if n is very large, no. If n is large, or I can say if n is tending to large value, if n is tending to large value, then sir, this probability of x taking value r could be changed to e to the power minus lambda, lambda to the power r divided by r factorial. Sir, how this expression came? In this expression, if you put n tending to infinity, then this is the answer that you will be getting. Do I need to put the limit? No need to put the limit. It will not be asked in the examination. You can derive it NCR p to the power r, q would be written as 1 minus p to the power n minus r, then it would be written as 1 minus p upon to the power r, 1 minus p to the power n, then you put n tending to infinity. You can find out the limit. Once you find out the limit, then eventually this is the expression you will be getting. E to the power minus lambda multiply with lambda to the power r divided by r factorial. Eventually, after putting all the values, this is the answer that you will be getting, where lambda is n into p, which is equals to expectation of random variable x. And this is known as Poisson's distribution. So x was following binomial distribution for sure. But if the number of trials has become larger, number of trials is 20, which is a bit larger number. So if the number of trials become larger, then the binomial distribution would become Poisson distribution. Poisson's distribution. Is that understandable to you? So condition of binomial distribution and Poisson distributions are same condition they are having. Only one thing is that number of trials should be independent for sure, but the number of trials would be a bit larger in number. Is that understandable to you? It will be a bit larger in number. That's it. Say yes or no. So with respect to this question, we understood that, sir, if I am solving this particular question, if this question is coming in my examination, then sir, this is how I will be solving it. I will get the answer 0.0476. Then I saw that, sir, here, if I define a random variable x, which is equal to the number of defective chips, then it would follow the binomial distribution. So, sir, I can apply the formula of probability of x taking the value r. That means I need to find out probability of x, random variable x taking value 1, which will be equals to 20c1 multiply with 1 by 400 to the power 1 multiply with 399 divided by 400 to the power 19. Now, sir, I can see that number of trials 20 is a bit larger number. If n is tending to infinity, then sir, NCR p to the power r, q to the power n minus r could be replaced as e to the power minus lambda multiply with lambda to the power r divided by r factorial, where lambda equals to n into p, which is equals to the expectation of random variable x. And when I put the values, I get the same answer. So this is your Poisson's distribution. This is known as Poisson's distribution. So if n is tending to infinity, then probability of this was your binomial distribution. So probability of random variable x taking value r would become e to the power minus lambda, lambda to the power r divided by r factorial, where lambda is expectation of random variable x. Expectation of random variable x. Expectation of random variable x, or you can say expectation of random variable x, and that is coming out to be equals to n into p. And this particular scenario is known as that x is following the Poisson's distribution. Now x is following Poisson's distribution. So Poisson's distribution and binomial distribution are nearly the same. Only condition is n would be tending to infinity, or n is very large. N is very large. That means what you can do, you can apply the formula of Poisson's distribution. Is that understandable to you? Okay. So binomial distribution and Poisson distribution are brothers of each other. It's just that every condition is same. Probability of success, probability of failure, only two possible outcomes should be there. All of them should be independent of each other. P plus Q should be equal to 1. Just number of trials are large enough. There we used to say that number of trials are finite, but here number of trials could be infinite. That's the only change when you move from binomial to Poisson's. If this question is coming in the examination hall, will I be applying Poisson's distribution or binomial distribution? No. This is how I will be solving it. But you just need to know the meaning here. Okay. So for Poisson's distribution, what is the mean? What is the mean? So sir, for Poisson's distribution, the mean is lambda. And what is the variance? What is the variance? So when I solve this, I find out the variance, then I notice one thing, that variance also comes out to be lambda only. So I am writing down one thing, for binomial distribution, what was the mean? Mean was n into p. And what was the variance? Variance was n into p into q. For Poisson's distribution, what is the mean? Mean is also lambda. And what is the variance? Variance is also equals to lambda only. Okay. And here in this case, what you have seen, mean equals to variance. Mean equals to variance. So for binomial distribution, what was the condition? For binomial distribution, the condition was that mean would be greater than variance. For Poisson's distribution, what is the condition? For Poisson's distribution, the condition is mean is equal to the variance. Okay. So these kind of small question could be asked, that for the binomial distribution, mean is greater than the variance. For the binomial distribution, mean is less than the variance. For binomial distribution, mean equals to variance. So answer would be, for binomial distribution, mean would be greater than variance. For Poisson's distribution, mean is equals to the variance. Is that understandable to you? And if someone would ask what is the value of lambda, so that would be equals to n into p. N into p. Okay. Now we will solve some questions, and those questions are very good actually. They will be based on Poisson's distribution. In the examination, either you will see this word, an average of 4 customer. So if you see the word average, an average of 4 customer, if you see this particular word, no, average of, then you would know that it will follow Poisson's distribution. But till this date, whatever the question that has been asked in the examination, everywhere it would be written that it is following a Poisson's distribution. So random variable is following the Poisson's distribution, it will be written. Okay. So what they are saying, assuming that number of calls received follows a Poisson's distribution, then find the probability that the support center receive exactly 6 calls in the next 1 hour. Okay. So what you are supposed to find out, probability that support center receive exactly 6 calls in the next 1 hour. So what is your random variable x? What you will define your random variable x as? So random variable x is number of calls received, because what is given, number of calls received follows a Poisson's distribution. So this particular line would be given in the examination hall. If this line is not given, let's just say this line is not even given. The question was, a customer support center receives an average of 4 customer calls per hour. Assume this line is not even given. Directly they are asking, find the probability that a support center X receive exactly 6 calls in the next 1 hour. If this is the question that they are asking, then an average, if this word is written, no, an average, then you would say, sir, they are talking about Poisson's distribution only. Is that clear to you? Either it would be Poisson's or it would be exponential as well. But sir, how we will differentiate between Poisson's and exponential, that we will understand in this lecture later on. But as of now, what you have understood, that this is following Poisson's distribution. So if question is based on Poisson's distribution, no, then we will have to maintain some patience. We will have some patience and we will write down. First target would be writing down the random variable x. What my random variable x is representing. Random variable x is representing number of calls received. Number of calls received. Number of calls received in an hour. Why I can write down in an hour? Because sir, they are asking exactly 6 calls received in 1 hour, in next 1 hour. So if I write down in an hour how many calls are received, then what you are supposed to find out? You are supposed to find out probability of x taking value 6. Say yes or no? Because what is probability of x taking value 6? Probability of x taking value 6 would be number of calls received in number of calls received in next 1 hour or in an hour should be equal to 6. Probability of number of calls received in an hour is 6. This is what we are supposed to find out. That means if I write down my random variable x as number of calls received in 1 hour, then I am supposed to find out probability of x taking value 6. This is what I am supposed to find out. Can I find out the expectation of x? What will be the expectation of x? Expectation of x would be, sir, expected number of calls received in an hour. Expectation of x would be nothing but expected number of calls received in an hour. That's it. ये क्या हो गया भाई? Expected number of calls received in an hour. So is it given? Expectation of x is given. Expected number of calls received in an hour. So a customer support receives an average of 4 customer call per hour. So expectation of x is given as 4. That will be equals to lambda. Say yes or no. So what you are supposed to find out? You are supposed to find out probability of x taking value equals to 6. So e to the power minus lambda, or let's write down probability of x taking value r, that is equals to e to the power minus lambda, lambda to the power r divided by r factorial. E to the power minus lambda, lambda is 4, 4 to the power r. What you are supposed to find out? You are supposed to find out x taking value 6, 4 to the power 6 divided by 6 factorial. So what will be the answer? 4 to the power e to the power minus 4, e to the power minus 4 into 4 to the power 6 into 4 to the power 6 divided by 6 factorial, 0.104. This is the answer that you are getting. I know you did not understand 100%, but have some patience. You will be able to understand it. Just have some patience. Okay. More questions we are going to solve. It will become more clear. Just have some patience. So whenever the question is coming on Poisson's distribution, first of all, we need to have some patience. What we will write down, our first target would be that write down the random variable x. How we will get to know what is our random variable x? We will see the last line. Find the probability that a support center receives exactly 6 calls in next 1 hour. That means your random variable x would be, and random variable x is number of calls received follow a Poisson distribution. So random variable x would be number of calls received in an hour. Can I find out expectation of x? Expected number of calls received in an hour would be equals to 6. So expectation of x also we can find out. What will be the probability that random variable x taking value 6? That we are supposed to find out. So I can simply apply the formula. Do e to the power minus lambda, lambda to the power r divided by r factorial. So can I apply the formula? Yes, you will get the answer. More questions we will solve, more it will become clear. A bookstore receives an average of 2 customer complaints per day. Okay, an average of 2 customer complaints per day. It will follow Poisson's distribution. Over a period of 100 days, how many days would you expect the bookstore to receive no customer complaints? How many days? They are asking some particular answer in terms of days. So I told you how many days you would expect. So if they are asking number of days or anything, our first focus will be towards the probability. So what I will find out? I will find out that probability of a bookstore receiving no customer complaint. So what is my first task? My first task would be probability of a bookstore receiving no customer complaint in a day. No customer complaint in a day. Complaint in a day. In a day. So if I am find out this probability, if I am able to find out this probability, then whatever the probability that I have got, if I multiply this with 1000 days, then whatever the answer that I get, that will be my final answer. Say yes or no. Did you understand this point or not? If I find out that what is the probability, what are the chances that in a day there is 0 customer complaint. In a day there is 0 customer complaint. What are the chances of that? And if I multiply that with 100, if I multiply that with 1000 days, will I get my answer? Yes sir, you will get your answer. So now my target is finding the probability that a bookstore is receiving no customer complaint in a day. Bookstore is receiving no customer complaint, or you can say 0 customer complaint in a day. What does that mean? What will be my random variable x? my random variable x would be number of customer complaint received in a day. Number of customer complaint, number of customer complaints received in a day. What you are supposed to find out? You are supposed to find out the number of customer complaints received in a day is equals to 0. This is what you are supposed to find out. Can you find out expectation of x? What will be expectation of x? Expected number of complaints received in a day. In a day. So that would be equals to, on an average 2 customer complaint per day, lambda. So probability of x taking value equals to 0. That would be equals to e to the power minus lambda, lambda to the power 0 divided by 0 factorial. That would be equals to e to the power minus lambda only. Lambda to the power 0 is 1, 0 factorial is also 1. So e to the power minus lambda, which is equals to e to the power minus 2. What is the answer? E to the power minus 2 is nothing but 0.13553. This is the answer that you are getting. So this probability you have received. So this is your question mark. This question mark you have received. So what is the scenario? That there is, if you write down in percentage, it will be 13.53%, right? So there is 13.53% chances are there that you will be receiving no complaints in the day, right? So if you multiply this with 1000, then if you multiply this particular thing with 1000, then what is the answer you are getting? 135.3 days. So it is expected that there would be roughly around 135 days where you will receive no complaints. Is that understandable to you or not? Is this question understandable to you or not? I know they are not very straightforward. So that's why I said that whenever the question is coming on Poisson's distribution, you need to have some patience. First of all, what you will do? Sir, here they are asking how many days would you expect? All these questions they are asking. Then I told you, if they are asking about the expectation, our first target would be to find the probability. So my first target, my first focus would be towards the probability. So probability of a bookstore receiving 0 complaints in a day, a probability of bookstore receiving 0 complaints in a day, this is the target that I am having. Now it is Poisson's distribution, then the first task would be to define the random variable. So what will be my random variable? So based on the question, this is the question, that probability of bookstore receiving no customer complaint in a day. That means my random variable x would be the number of complaint received in a day. Number of complaints received in a day. So what I am supposed to find out? Number of customer complaints received in a day would be equals to 0. This is what I am supposed to find out. This is what I am supposed to find out. This is my target. Now can I find out expectation of x? Sir, for finding this particular thing, what I need? I require the value of lambda. What is lambda? Lambda is expectation of x. Can I find out expectation of x? Yes sir. Expectation of x would represent expected number of complaints received in a day. That would be equals to 2. So e to the power minus 2 is the answer. There you go. So probability that a bookstore is receiving no customer complaint in a day is equals to 0.1353. So in 1000 days, how many days would be there where they will receive no customer complaint? So simply multiply with 1000, your answer would be 135.3 days. So roughly around 135.3 days would be there, or answer would be 135 days would be there that they will receive no complaints. So in the examination, in the options, 135 would be mentioned. So 135 days are expected to receive no customer complaints. Very good kind of questions, very good level of question, but you would be able to solve in a very great manner. How you would be able to solve? By having some patience. If the question is based on Poisson's distribution, first of all, I need to have some patience. Then I need to see what they are asking. Keep on writing down the things and eventually you will get the answer. Let's try solving the next question. What they are asking? A customer support receives an average of 3 customer calls per day. Assume that the number of calls received in an hour follows, not in a day, per hour. It is 3 customer calls per hour. Assume that this is following Poisson's distribution. Find the probability that in next 1 hour, customer receives at most 2 calls, more than 2 calls, at least 2 calls. So first one, what they are asking? Probability that in next 1 hour, the support center receives at most two calls. So the support center receives at most 2 coals. What does that mean? What will be my random variable x? And it is given as well. And in next 1 hour they are talking about. They are talking about next 1 hour. So what will be my random variable x? The number of coals received in an hour. My random variable x would be number of coals received in an hour. Coals received in an hour. Say yes or no. This will be my random variable x. Can you find out expectation of x? Expected number of coals received in an hour. Expected number of coals received in an hour is 3. So expectation of x is 3 coals an hour. 3 coals per hour. Or expectation of x is simply 3, which will be equals to lambda. First question what they are asking. At most 2 coals. That means there could be 0 coals, or there could be 1 coal, or there could be 2 coals. If I say bring at most 3 apples for me, bring at most 3 apples for me. So if you bring 0 apple, still I will be fine. If you bring 1 apple, still I will be fine. If you bring 2 apples, still I will be fine. If you bring 3 apples, still I will be fine. But if you bring 4 apple, will I be fine? No, because I told you at most 3 apples. Right? At most 3 apples, that means either 0 or 1 or 2. So this would be equals to e to the power minus lambda, lambda to the power 0 divided by 0 factorial. E to the power minus lambda, lambda to the power 1 divided by 1 factorial. E to the power minus lambda, lambda to the power 2 divided by 2 factorial. So that would be equals to e to the power minus lambda, this is 1 only, plus lambda square divided by 2. So e to the power minus lambda, this is 3. 1 plus 3 square divided by 2. So if you have some patience, then you will be able to solve these questions. Otherwise, you will be struggling. So you need to have some patience to solve these kind of questions in the examination hall. Okay? Because Poisson's distribution would require some patience. Just have some patience and you will surely get the answer. So 0.423. So this is the probability 0.423, but we need to solve all other questions as well. So this is the answer of first one. This question could have been asked in a way that in the next 20 hours, how many hours are expected? In next 20 hours, how many hours are expected to receive at most 2 calls? So what you would do? That sir, in 1 hour, there is the probability that you would receive at most 2 calls. The probability is 0.423. So in next 20 hours, what you would do? 0.423 multiply with 20. So 0.423 multiply with 20. The answer I am getting, that is 8.46. So in next 20 hours, there will be roughly around 8.5 hours in which you will be receiving at most 2 calls. Are you able to understand this point? If the question was, let me know the expected number, let me know in the next 20 hours, how many hours are expected such that I will receive at most 2 calls. So first of all, what will be my target? Probability that I receive at most 2 calls in the next 1 hour. So that probability I will find out. And after that, I will multiply with 20. So that will be the answer. Understandable? Next, more than 2 goals. More than 2 goals. What they are asking? Next question is probability of receiving more than 2 goals. More than 2 goals. That means they are asking x equals to 3, or x equals to 4, or x equals to 5. Or you can receive 6 calls, or you can receive 10 calls, or you can receive infinity calls. So can I write it down in this manner? Probability of receiving either 0 calls, or 1 call, or 2 calls. Say yes or no. Because they are asking more than 2 calls. More than 2 calls. So 1 minus at most 2 calls. So 1 minus 0.423. 1 minus 0.423. So what will be the answer? 0.577 is the answer. At most 2 calls. Next, at least 2 calls. At least 2 calls. Bring at least 2 apple for me. So if you bring 2 apple, then also I am fine. If you bring 3 apple, then also I am fine. If you bring 4 apple, then also I am fine. If you bring 5 apple, then also I am fine. That means what they are asking, at least 2 calls. At least 2 calls. At least 2 calls. So if you bring either 2 apples, or you bring 3 apples, or you bring 4 apples, or you bring 5 apples, everything would be fine for me. Have I already find out this value? This value I have already find out, that is 0.577. I am only supposed to find out this value, which will be e to the power minus lambda, lambda to the power 2 divided by 2 factorial. So e to the power minus lambda, lambda is 3. E to the power minus 3, 3 to the power 2 divided by 2. So 9 by 2 e to the power multiply with divided by 2 into 9. So 0.224. So what is the answer? 0.224 plus this answer. So answer would be 0.224 plus 0.577. 0.577. So answer is 0.8. That's the answer. Answer is 0.8. This is the answer that we are getting. Is that clear to you? So with the patience, read the question, you will be able to solve. On an average, although directly it is given that it is following Poisson distribution, till this date, all the question that has come in the GATE examination, they have given it is following Poisson distribution. Even if they are not giving Poisson distribution, still I will be able to understand with an average of 3 customer calls per hour. So what is my random variable x? Number of calls received in an hour. How did I find out? Probability that in next 1 hour the number of customer call received. This is the question they are asking. So based on that, I understood that my random variable x would be number of customer call received or number of calls received in an hour. So expectation of x I already know. What will be the expectation of x? Expectation of x would be expected number of calls received in an hour. That would be equals to 3. That is already given. Now at most 2 calls, that means either you get 0 call or you get 1 call or you get 2 call. Then next, all these questions. Next question, let's solve it. Solve this question, you will be able to solve, and you should be able to solve this question on your own. You should not get it wrong. So during 800 working hours, how many hours would you expect the call center to receive exactly 2 complaint calls? What does that mean? What is your random variable x? What will be your random variable x? Number of calls received in an hour. That's it, right? Number of calls received in an hour. Number of calls received in an hour. What will be your expectation of x? Number of calls received in an hour. Expected number of calls received in an hour. On an average, 1.5 calls are received per hour. What you are supposed to find out, during 800 working days, how many hours would you expect? So number of hours they are asking, my focus will be towards the probability. So what I am supposed to find out? Probability that the call center receive exactly 2 complaints. What I am supposed to find out? First of all, I am supposed to find out probability that exactly 2 calls are received. Exactly 2 calls are received. Probability that exactly 2 calls are received. Probability that exactly 2 calls are received. Right? Probability that exactly 2 calls are received. This is what I am supposed to find out. Understandable? So can I find it out? Probability that exactly 2 calls are received. So that would be equal to nothing but e to the power minus lambda, lambda to the power 2 divided by 2 factorial. E to the power minus 1.5, 1.5 to the power 2 divided by 2 factorial. Square divided by 2 multiply with e to the power minus 1.5. So answer is 0.251. This is the answer that you are getting. So there is a 0.251 probability that we will receive exactly 2 calls in the next 1 hour. Probability that exactly 2 calls are received in 1 hour. In 1 hour. In 1 hour. In 1 hour. So what they are asking, during 800 working hours. So during 800 working hours, how many hours would be there that you would expect them to receive exactly 2 calls? So 0.251 multiply with 800. So what is the answer you are getting? Roughly around 200 hours, 200.81 hours, 200.82 hours. So roughly around 200.82 hours would be there where you would receive exactly 2 calls, exactly 2 complaint calls. So answer would be roughly around 200 or 201 you can say. Okay, 200.82 hours would be there where you would receive exactly 2 complaint calls. Is that understandable to you or not? Is this question understandable? That how I will read the question, how will I solve in the examination hall? This is how I will be solving that, sir. How many hours would you expect the call center to receive exactly 2 complaint calls? That means your random variable x would be that number of calls received an hour, number of calls received in an hour. So expectation of x would be expected number of calls received in an hour, that would be equals to 1.5. Probability that exactly 2 calls are received. Why I am finding the probability? Because I told you, no matter whatever the question they are asking, how many hours, how many calls, if these kind of questions they are asking, eventually you will have to multiply your answer with 800. So what I would do, I would put my focus towards 1 hour. So in 1 hour, what is the probability that I will be receiving exactly 2 complaints? That I need to find out. That I have find out. Multiply with 800 is my answer. All the question you see, whatever they are asking, with patience we are solving, then we will be able to solve. Otherwise, we will not be able to understand a single line in the examination hall. So you need to have some patience. Solve this question with patience. It is a bit tricky, because what they are asking, probability that exactly 1 aircraft land in the next 15 minutes, but data is given 8 aircraft landing every hour. Assuming that aircraft landing follow a Poisson distribution, find the probability that exactly 1 aircraft lands in the next 15 minutes. So what would be your random variable x? Random variable x would be, sir, number of aircraft landing. This is what you would say, that sir, my random variable x is number of aircraft landing. After that also you need to write down something, no? Here what was the random variable x? Number of calls received in an hour. Here what was random variable x? Number of calls received in an hour. Here what was random variable x? Number of customer calls received in a day. Right? In an hour, in a day. So there is a time window. There is a time window. Here what was the scenario? In next 1 hour, how many calls are received? The data is also given for per hour. Here what is the scenario? Basically here as well you need to talk about in a day, and data is also given for per day. Here what is the scenario? You need to talk about next 1 hour. Here also data is also given for per hour only. But here what is the scenario? In this question what is the scenario? That you need to find out for next 15 minutes, but data is given for every hour. So if I assume my random variable x is number of aircraft landing in an hour, let's just say I assume my random variable x number of aircraft landing in an hour. This is my random variable x. Let's just say I assume this. Will I be able to tell you expectation of x? Yes sir, expectation of x would be number of aircraft landing, expected number of aircraft landing in an hour. So expected number of 8 aircraft will be landing in an hour. So expectation of x would be, sir, equals to 8. But what they are asking, find the probability that exactly 1 aircraft land in the next 15 minutes. So if I say I am finding probability of x equals to 1, what this would represent? Probability such that random variable x is taking value 1. That means probability such that probability that it would represent probability that exactly one aircraft lands in an hour. Say yes or no? So P x taking value 1 is representing that probability that exactly 1 aircraft landing in an hour, not in 15 minutes. So this is what you are not supposed to find out. This is not your answer. What is your answer? You are supposed to find out probability that exactly 1 aircraft lands in next 15 minutes. That is your answer, no? Right? So what does that mean? That means this process will not be helpful. What I need to do is that I need to assume my random variable x number of aircraft landing in next 15 minutes. Number of aircraft landing in next 15 minutes. This will be my random variable x. Is that understandable to you? Is that understandable? Why this is my random variable x? Because in every question what I was doing, I was defining my random variable x from here. If you noticed one thing, if you notice the explanation of next if you notice the explanation of last questions, I always defined my random variable from here, from the last line. I always defined my random variable from the last line. In the next 1 hour, support center receives. So number of calls received in an hour. So always you will need to define your random variable x from the last line. So random variable x is number of aircraft landing in next 15 minutes. So now what I am supposed to find out? I am supposed to find out probability of x equals to 1. What does that mean? Probability that exactly one aircraft land in next 15 minutes. This is what I am supposed to find out. Next 15 minutes. So that would be equals to e to the power minus lambda to the power r divided by r factorial. Right? E to the power minus lambda to the power r divided by r factorial. What is the value of lambda? Lambda is, sir, expectation of x. That means expectation of x is expected number of aircraft landing in next 15 minutes. Expected number of, so let me do one thing. Let me add a page and let me write down what will be your lambda. So lambda will be nothing but expectation of x, that would be equals to expected number of aircraft landing, aircrafts landing in next 15 minutes. Say yes or no. So lambda is expected number of aircraft landing in next 15 minutes. So what is given? In 1 hour 8 aircraft should land. That means in 60 minutes 8 aircrafts are expected. So in 15 minutes how many aircrafts would be expected? That would be 8 by 4. That would be 2. So that would be equals to 2. So probability of x taking value equals to 1. That would be e to the power minus 2 multiply with 2 to the power 1 divided by 1 factorial. .27. So this is the probability that you will be getting. This is the answer that you are getting. So answer is 0.27. So did you understand? This is the next kind of question. This is the next pattern of the question. In this pattern, what they are asking? In this pattern, they are asking find the probability that exactly one aircraft lands in the next 15 minutes. So this time the data given for average and the data that they are asking for the probability, they are different. They are giving the data for per hour, but here they are asking for next 15 minutes. That means we will have to use the data. We will convert this data into next 15 minutes. So 8 aircraft per hour, 8 aircraft per hour is equivalent to 4 aircraft per 15 minutes. This was the important point. No, see, this is equals to 4 aircraft per 15 minutes. This would be equals to 2 aircraft per 60 minutes. So 8 aircrafts per hour is equals to 2 aircrafts per 15 minutes. Okay, is that clear to you? So the data, so random variable x is number of aircraft landing in next 15 minutes. So number of aircraft landing in next 15 minutes is your random variable x. You need to find out expectation of x, that will be expected number of aircraft landing in next 15 minutes, that will be equals to 2. Expected, now probability of x taking value equals to 1. What does that mean? That means the number of aircraft landing in next 15 minutes should be equals to 1. This is what we are supposed to find out. I hope you are solving with the patience. If you are solving with the patience, then you will be able to solve. So this question is also done. Let's go to the next one. A fire station receives an average of 0.8 emergency call per night. Assume that the number of emergency call received the Poisson distribution over the next 500 nights. How many nights would you expect the fire station to receive exactly one emergency call? The fire station to receive exactly one emergency call. What do you think? What will be your random variable x? Random variable x will be number of emergency call received. Calls received. Can you let me know what will be the number of emergency calls received in next 500 nights, that means you are talking about per night. Per night. So number of emergency calls received per night. So can you let me know expectation of x? Expectation of x would be number of emergency calls received per night. So expected number of calls emergency call received per night, which is equals to 0.8. What will be the probability of x taking value? Would you expect the fire station to receive exactly one emergency call? So probability of x taking value equals to 1. So that would be equals to probability that the fire station receive exactly one emergency call per night. Probability that fire station receives exactly one emergency call per night. So what will be this probability? So this probability will be equals to e to the power minus lambda, lambda to the power 1 divided by 1 factorial. So e to the power minus 0.8 multiply with 0.8 divided by 1. 0.8 plus minus e to the power 0.8 multiply with 0.8, answer is 0.359. 0.359. This is not the final answer. This is just the scenario that there is 0.359 probability that in one night you will be receiving exactly one emergency call. So in 500 nights, how many nights would be there? In 500 nights, how many such nights would be there? In 500 nights, how many such nights would be there? So in 500 nights, roughly around 179.73 nights would be there. 179.73 nights would be there where you will be receiving exactly one emergency call. So answer would be roughly around 180 nights. Answer would be roughly around 180 nights. So did you understand this kind of question or not? Say yes or no. So how you solve these kind of problems, that is completely clear to you or not? Again I am telling, whenever the question is based on Poisson's distribution, first of all an average of this kind of language would be written. You will be able to understand. Most of the chances are there that in the examination they themselves will say that it is based on Poisson's distribution. So then you would understand that, sir, my target would be now to frame my random variable x. If the question is based on binomial distribution, then how will you solve? By the basic concept of probability. You will not apply any formula. But if the question is based on Poisson's distribution, you will have to apply the formula. Probability of x taking value equals to r is e to the power minus lambda multiply with lambda to the power r divided by r factorial. So first my target would be to find out the random variable x. So the random variable x would be number of emergency call received per night. Expectation of x would be expected number of emergency call received per night, that would be equals to 0.8. Now what you are supposed to find out? They are asking how many nights. That means first my target would be that in one night, what is the probability that I will receive exactly one emergency call. So I am supposed to find out probability of x equals to 1. So e to the power minus lambda, lambda to the power 1 divided by 1 factorial, e to the power minus 0.8 multiply with 0.8, 0.359. That means there is 0.359 probability that in one night I will receive exactly one call. So in one night exactly one call. Then in 500 nights, what will be, how many nights would be there that you will receive exactly one call? So you will multiply with 500. So your answer would be 500 into 0.359. Answer would come out to be 179.73. Understandable? Very good. A very good question. And this I would say it was a very straightforward question. You should be able to solve after solving these many problems. After solving these many problems. I know the Poisson distribution is a bit different kind of distribution. That's why we are solving a lot of questions. One question we have solved, 2, 3, 4, 5, 6. 6 questions we have solved. Later on we will solve more questions. Understandable? Let's solve next question. A network router receives an average of 10 data packets per millisecond. Assume that the number of data packets received follows a Poisson's distribution. Then find the probability that exactly 5 data packets arrive during the next 3 milliseconds. What will be your random variable x? So random variable x would be number of data packets received, number of data packets received in 3 milliseconds, right? Why 3 milliseconds, sir? Data is given for per millisecond, no? Why 3 millisecond? Because you read the last line, you need to find out the packets arrived during the next 3 milliseconds. That means your random variable x would be number of data packets received in the in the 3 millisecond. So what will be the expected expectation of x? So it would be expected number of data packets received in the next 3 milliseconds. So in 1 millisecond you receive 10 data packets. In 1 millisecond you are expected to receive 10 data packets. So in 3 milliseconds you are expected to receive 30 data packets. So 30 data packets per 3 millisecond. This is per millisecond. If you multiply with 3, so 30 data packets per 3 millisecond you are expected to receive. Now what you are supposed to find out? You are supposed to find out probability that exactly 5 data packets arrive in the next 3 milliseconds. So probability that exactly 5 data packets would arrive. So e to the power minus lambda to the power 5 divided by 5 factorial. So e to the power minus 30 multiply with 30 to the power 5 divided by 120. So that's the answer. 30 to the power 5. 30 to the power 5 divided by 120 multiply with e to the power minus 30. So answer is coming out to be 1.89 into 10 to the power minus 8. That's the answer. So very less probability is there. No, it is nearly 0. It is nearly 0, right? It is nearly 0. This is the answer. Okay. So probability that you will be receiving exactly 5 data packets during the next 3 milliseconds, that would be 1.89 into 10 to the power minus 8. So with the patience, I will read the question and I will be able to solve it. What my patience is saying, that you read the last line, probability that 5 data packets, so number of data packets received or number of data packets arrived in next 3 milliseconds. This is my random variable x. So in 1 millisecond I am receiving 10 data packets. So in 3 milliseconds I will receive expected 30 data packets. So expectation of x is 30. What I am supposed to find out? I am supposed to find out that you are receiving exactly 5 data packets. So probability of x equals to 5. Job done. Understandable? Let's go to the next question. This question is based on exponential random variable. So now what we are going to do is that we are going to study exponential random variable and then we will relate exponential random variable with Poisson's distribution. Okay. So exponential and Poisson's are related with each other, but let's study about exponential first, and then what you will see is that we will solve these kind of problems where Poisson's and exponential are related with each other. So just have some patience and solve this question, and then we will relate exponential with Poisson's. Okay. So this question is given a random variable x. It is a continuous random variable x which is having this probability density function. This is the PDF is given. First of all, you need to find out, is it a valid PDF? So what is the first question? Is it a valid PDF? So what is the condition? Sir, minus infinity to infinity fx of x dot dx. If it is representing 1, then it will be a valid PDF. Right? Otherwise it will not be valid. So minus infinity to infinity. This is only for x greater than or equals to 0, no? So alpha e to the power minus alpha x dot dx, it is applicable for only for x greater than 0. So here I will put 0 only. So if I integrate this, what answer I will be getting? Alpha is a constant value, e to the power minus alpha x divided by minus alpha, limit going from 0 to infinity. I will solve it. I am getting the answer to be 1 only. So is it a valid PDF? Yes, it is a valid PDF. Surely it is a valid PDF. What will be its mean? So I am supposed to find out the mean. So mean of random variable x. So that is given as minus infinity to infinity x dot fx of x dot dx. So minus infinity to infinity x dot, what is fx of x? Fx of x is alpha e to the power minus alpha x dot dx. But I will change the limit from 0 to infinity because it is applicable from 0 to infinity only. So I will change the limit from 0 to infinity. So if I solve it, can you solve it? So alpha is a constant value, take it outside. First, as it is, integration of second minus differentiation of first, integration of second, and then the integration of whole. This is the answer that you will be getting. Limit going from 0 to infinity. So when you put the values, you will get, if you put infinity here, this integration you can do on your own. In the calculus, we have studied this kind of integration with the concept of a gamma function, right? So you can apply the gamma function, or this islet formula also you can apply. So when you apply the formula, you will see that expectation of x is coming out to be 1 by lambda. Okay. Is that clear to you? And now what next we are supposed to find out? We are supposed to find out the variance of x. Next we are supposed to find out, third we are supposed to find out variance of x. variance of x, right? That means we are supposed to find out sigma x square. So that would be expectation of x square minus expectation of x whole square, right? This is what we are supposed to find out. So you do this calculation on your own. What you already know, expectation of x square, this value you already know. You find out expectation of x square. This is your target. So that would be equals to 0 to infinity. Why I am putting 0 to infinity? Sir, actual formula is minus infinity to infinity x square fx of x dot dx. 0 to infinity x square alpha e to the power minus alpha x dot dx. Do this calculation on your own and let me know your answer. Let me take a break, drink some water, and then I will come back. You solve this question on your own, you will be able to solve in a very easy manner, and let me know what answer you are getting. And from there, you let me know what is the variance value you are getting. Okay, you need to do it on your own. I am not going to do the calculation. You should be doing on your own and let me know what is the variance you are getting. Let me take a break and then I will come back. Okay. Yeah, welcome back. So did you solve it? So what is the answer you got? You can solve it using the concept of gamma function or any one. Okay, you can directly solve by islet or you can use the concept of gamma function. So answer you will get is 2 by alpha square. So expectation of x square is coming out to be 2 by alpha square. It is coming out to be 2 by alpha square minus expectation of x is 1 by alpha, so square of it will be 1 by alpha square. So what is the variance you are getting? So variance I am getting is 1 by alpha square. So from here, what is the conclusion that we are getting? The conclusion is that, sir, this is my exponential random variable. Okay, or you can say x is following the exponential distribution. X follows exponential distribution. Exponential distribution. Okay, x follows exponential distribution. So if x is following exponential distribution, then its PDF is written by alpha e to the power minus alpha x for x greater than equals to 0. Okay, what is its mean? Sir, mean came out to be 1 by alpha. And what is the variance? Sir, variance came out to be 1 by alpha square. So this much you are supposed to remember. So let's write down the conclusion of all three distribution that we have studied. Binomial distribution. So in binomial distribution, what was our PMF? Sir, PMF was probability of random variable x taking value r equals to NCR p to the power r q to the power n minus r. What was the mean? Sir, mean was nothing but n into p. And what was the variance? What was the variance? Sir, variance was n into p into q. This is your variance of x. For Poisson's distribution, what is the probability of random variable x taking value r? So that is e to the power minus lambda, lambda to the power r divided by r factorial. Lambda could be related as n into p. What is the expectation of x? What is the expectation of x? That is lambda. And what is the variance of x? What will be the variance of x? Or you can call it sigma x square. That was also lambda only. Both were same. Expectation and variance both were same. For exponential distribution, what is the PDF? Sir, PDF is alpha e to the power minus alpha x with x greater than equals to 0. What is the mean? Sir, the mean that we are getting is 1 by alpha. And what is the variance? So the variance that we get is 1 by alpha square. There you go. So this is the conclusion that we are supposed to remember. Is that clear to you? So exponential distribution is alpha e to the power minus alpha x. Now we are going to understand that what is the relation between Poisson's distribution and exponential distribution. Because in the examination, if the question is coming on binomial, will I solve it using the concept of binomial distribution? Will I apply this formula in the examination hall? No. I will solve by my basic concept of probability. But if the question is coming on Poisson's, how will I solve? This is how I will solve. A lot of questions we have solved. And if the question is coming on exponential, then also I may have to apply the formula. So what we are going to see now, we are going to see that how we will understand whether it will show Poisson's distribution or it will show exponential distribution, that we are going to see. So Poisson's distribution will always answer how many. That means how many people, how many vehicles, how many customers. So it will always talk about the number. Poisson distribution always talks about the number, and exponential distribution will always talk about how long until. That means it will talk about the time. It will talk about the time. Number of vehicles arriving at a toll plaza in 10 minutes, that will be showing Poisson's distribution. But waiting time until the next vehicle will arrive, that will show exponential distribution. Wait time, if you are talking about the time, exponential. If you are talking about number, Poisson's. Let's see all the examples. Everywhere we are talking about number only. Everywhere. The number of calls. X is the number of emergency calls. Number of data packets. Number of aircrafts. Number of calls. Number of calls. Number of customer complaints. So everywhere we are talking about the number of calls received. So when it is about Poisson's distribution, we will always talk about the number. Here what is written? Just one second. Here this we forgot. 1.89. Yeah. So always we will talk about the numbers when it's about the Poisson's distribution. Number of customer entering into the bank. But here waiting time until the next customer arrive. Let's just say this is my bank. Okay. So here at t equals to 0, one customer has come. One customer has come. Now when the next customer will come? So between first customer and second customer, what is the time? That time will represent the exponential distribution. Is that understandable to you? Are you able to understand this point? So when it is about the time, waiting time, number of phone calls received by a call center in 1 minute, Poisson distribution. Waiting time until the next phone call, that will be exponential. Number of requests, Poisson's. Waiting time until the next request, exponential. Number of radioactive particles, Poisson's. Time until the next radioactive particle is emitted, that will be exponential. Number of emails, Poisson's. Waiting time until the next email arrive, exponential. This is a GATE PYQ only. This question is asked in GATE examination. Let me know what kind of a distribution it is. If calls arrive at a telephone exchange such that the time interval between any two consecutive calls is independent of the time interval between earlier or the future calls, then the probability distribution of the total number of calls received in a fixed time interval is number of calls received, Poisson's. Now who knows in the future examination if this question is coming, then the possible distribution of the time interval between two successive calls, what kind of distribution it would be? Exponential. Is that clear to you? Number means number means Poisson's. Okay, and time means exponential. That's it. Will you be able to remember it or not? Certainly sir, I will be able to remember it. That's it. Okay, let's solve this question. Let's just say if this was not given, assuming that the service follows an exponential distribution, although in 99% chances are there that it will be given, but still will you be able to understand? At a customer service, the average service time per customer is 12 minutes. So find the probability that you will have to wait time between 8 and 18 minutes before your service begins. That means they are talking about the time only. So let's read the question again. At a customer service, the average time per customer is 12 minutes. Assuming that service follows an exponential distribution, you arrive just after another customer has begun receiving the service. So what they are saying that let's just say you are going into a phone customer service. So one customer will take on an average 12 minutes. And at a time they will deal only one customer only. So let's just say one customer has arrived here. Some customer has arrived here. He is standing here. So on an average he will take 12 minutes. Now you are the next guy in the row. You are the next guy in the queue. So what is the probability that you will have to wait between 8 to 18 minutes? What is the probability? This is what they are asking. So what I can assume? My random variable x. Random variable x is find the probability that you will have to wait between 8 to 18 minutes before your service begins. So can I assume my random variable x as wait time? Now what I am supposed to find out? I am supposed to find out that my wait time should be between 8 minutes to 18 minutes. This is what I am supposed to find out. X is following the exponential distribution. Exponential distribution. X is following the exponential distribution. So can you let me know what will be its PDF? Sir, PDF will be alpha e to the power minus alpha x with alpha greater than, sorry, not alpha, with x greater than equals to 0. Now, can you let me know what is the expectation of x? What is your expected wait time? Expected wait time. So, sir, my expected wait time is 12 minutes. Expected wait time is 12 minutes. Expected wait time is 12 minutes. So, expectation of x is given as 12. So, if this is my PDF, what will be the expectation of x? Do you remember that? So that is equals to 1 by alpha. Here only we have find out expectation of x is 1 by alpha. So that means from here, sir, I have got to know that value of 1 by alpha is 12 minutes. So from here, what is the value of alpha I am getting? That is 1 by 12. Is that clear to you? So value of alpha is 1 by 12. So what will be the PDF? Fx of x will be 1 by 12 e to the power minus x by 12 with x greater than equals to 0. There you go. This is the PDF. Now you are supposed to find out the probability such that x is between 8 to 18 minutes. X is between 8 to 18 minutes. Random variable x is taking values between 8 to 18 minutes. So random variable x taking value between 8 to 18 minutes. Fx of x dot dx between 8 to 18 minutes. What is fx of x? 1 by 12 e to the power minus x by 12 dot dx. So 1 by 12 outside, e to the power minus x by 12. So here multiply with 12, 8 by 18, but there will be a negative sign outside. Is that understandable to you? E to the power minus x by 12. I did the integration of e to the power minus x by 12. So divided by 1 by 12. So 12 will come here, right? So what you are getting? E to the power minus 8 by 12 minus e to the power minus 18 by 12. 18 by 12. Understandable? This minus sign I took inside, so limits can be interchanged. So e to the power minus 8 by 12 minus e to the power minus 18 by 12 and 12 is getting cancelled out. So this is the answer that we are getting. So now we are supposed to do this calculation. So e to the power minus 8 by 12. So first of all I will do 8 by 12, then plus minus sign e to the power minus 8 by 12, that will be 0.513 minus e to the power 18 by 12, 0.2231 minus 0.513, 0.289. That's the answer. So probability that you will have to wait between 8 to 18 minutes is 0.289. That's the probability. 0.289 or 0.29. Understandable? All clear? Now let me explain one more thing here. What was your expectation of x? Let's understand something else. What was your expectation of x? Your expectation of x was 12 minutes, right? Expectation of x was 12 minutes, right? 12 minutes. And what was your PDF? That was alpha e to the power minus alpha x. Now I know that, sir, I will have to integrate for the answer of my probability. What I will do, I will have to integrate 18 to from 8 minutes to 18 minutes. This is what I will have to integrate from 8 minutes to 18 minutes. Alpha e to the power minus alpha x dot dx, right? Now let's just say alpha I take outside, e to the power minus alpha x divided by alpha will also come because I am integrating it, and then alpha outside. Now 8 minutes, 18 minutes. Now what I will do, I will put the limits. Here minus is outside, e to the power minus alpha into 18 minutes minus e to the power minus alpha into 8 minutes. Now you notice one thing, e to the power minus 2 kg, will it make any sense? What is the answer of e to the power minus 2 kg? It doesn't make any sense, no? Senseless. It is senseless, right? E to the power minus 2 kg is senseless. E to the power minus 2 is e to the power minus 2 will make any sense, right? Are you able to understand this point? E to the power minus 2 kg will not make any sense. No, basically if there is something exponential to the power something, so this value has to be unitless. Say yes or no? If e to the power something is there, then this particular value has to be unitless. So similarly, this particular thing has to be unitless. Alpha into 18 minutes has to be unitless. So from here, what you can conclude? The unit of alpha has to be 1 by minute. Unit of alpha has to be 1 by minute. Unit of alpha has to be 1 by minute. So from here, if expectation of x I am writing down as 12 minutes, expectation of x I am writing down as 12 minutes. So without even thinking much, I can write down that alpha will be 1 by 12 minutes. 1 by 12 minutes. Because the unit would be 1 by minutes only. The unit has to be 1 by minute. So it has to be reciprocal of that. Although you know that, sir, expectation of x for exponential distribution, that is equals to 1 by alpha only. So alpha will be 1 by 12 only. But if you need to play with the units, just think about it, that what could be the value of alpha. So the value of alpha has to be 1 by minute only. It is necessary. The unit of alpha has to be 1 by minute only. This is necessary. The unit of alpha has to be 1 by minute only. Why it is necessary? I hope that is clear to you. Say yes or no. Why unit of alpha has to be 1 by minutes? It is clear to you or not? Absolutely clear, sir. Because, sir, it will become e to the power minus alpha x, and the limit of x I am putting in terms of minutes only. You need the time to be between 8 minutes to 18 minutes. So, sir, this x has to be in minutes. So alpha has to be 1 by minute. That's it. So unit of alpha has to be 1 by minute. Is that clear to you? Try solving this question, a very, very good question, and the similar kind of question has been asked in GATE examination as well. Not the exact same question, but the similar kind of question. A very, very, very good question. Just think about it. Customer arrive at a supermarket billing counter according to Poisson's process with an average arrival rate of 24 customers per hour. That means in 1 hour, 24 customers are arriving. Find the probability that time between two successive customer arrival is between 2 to 5 minutes. What they are asking? Probability that time between two successive customer arrival. So what is my random variable x? My random variable x will be time between two successive customer arrival, right? And what I am supposed to find out? I am supposed to find out that random variable x is between 2 minutes to 5 minutes. 2 minutes to 5 minutes. From 2 minutes to 5 minutes. This is what I am supposed to find out. And if they are talking about the time or wait time, that means this will follow exponential distribution. Exponential distribution. But sir, in the question something else is given. Sir, in the question they are talking about Poisson's distribution. They are talking about Poisson's distribution. Read the question again. No, they are talking about the arrival rate. That means customer per hour. 24 customer per hour. That is following Poisson's distribution. They are not talking about the wait time. They are talking about the number of customer arriving per hour. What they are saying? Number of customer arriving per hour. Number of customer arriving per hour. Arriving per hour. They are saying that this is following Poisson's distribution, which is absolutely correct. This is following Poisson's distribution. Is it correct? Absolutely yes, sir. Distribution. But the wait time will follow which distribution? It will follow the exponential distribution for sure. So in the examination, just to confuse you, they have written the name of Poisson's distribution. But if your concept is clear that sir, number will surely represent the Poisson's distribution, but sir, the time would represent the exponential distribution, then you will not be worrying at all. Right? That means what will be the PDF of x? Sir, here the PDF of x will be alpha e to the power minus alpha x with x greater than 0. What you are supposed to find out? Sir, my probability such that wait time is between 2 minutes to 5 minutes. Sir, that would be given as between 2 to 5 alpha e to the power minus alpha x dot dx. This is what I am supposed to find out. As of now, I don't have the value of alpha. What I am supposed to find out? I am supposed to find out the value of alpha. I know one thing, that sir, expectation of x will be given by 1 by alpha. And expectation of x would be average time between two successive customer arrival. Average time between two successive customer arrival. So can you find out this average time? Can you find out this time or not? Average time between two successive customer arrival. This is what we are supposed to find out. So what is given? Then it is given that in 60 minutes on an average 24 customers are coming. In 60 minutes on an average 24 customers are coming. So in 1 minute, how many customers are coming? 24 by 60 customers. 24 by 60 customers. So 24 by 60 customers are taking 1 minute. That means one customer would take 60 by 24 minute. Say yes or no. Are you able to understand this point? So let's just say first customer came at t equals to 0. At t equals to 0, first customer came. At 0 minute, first customer came. So at t equals to 60 by 24 minute, the second customer would come, no? The second customer would come. So what is the average time? What is the expected average time, or what is the average time between two successive customers? What is the average time between two successive customers? So between two successive customers, sir, the average time is 60 by 24 minutes. That means, sir, expectation of X has come out to be 60 by 24 minutes, which is equals to 1 by alpha. So from here, value of alpha is 24 by 60, which is 0.4. And is it equals to 1 by minute? What is the unit? Unit will be 1 by minute only, no? Why 1 by minute? So it is 60 by 24. 60 by 24, the unit is minute. If you take it reciprocal, then what will happen? Reciprocal of minute also you will take, no? So it will become 1 by minute. So 24 by 60 per minute. So it is having a unit of 1 by minute. And for sure it will have a unit of 1 by minute only. In the examination, if you don't need to think too much, no? If you don't want to think too much, then what you would think? So 24 customer per 60 minutes. Per 60 minutes. 24 customer per 60 minutes. This is what they have given. Right? So that's it. This will be the value of alpha. Because I know that, sir, unit of alpha has to be 1 by minute only. Why is that so? Because, sir, I am finding between 2 minutes to 5 minutes. That means X will have the unit of minute. So alpha will have the unit of 1 by minute. That means you need to find out something that has the unit of 1 by minute. So 20 by 60, you are getting 20 customer per 60 minutes. Job done. 24 by 60 will be my answer. Value of alpha will be 24 by 60. That's it. If you don't want to think too much, here I am explaining that's why I need to explain the meaning of everything. But just by this scenario, if someone is smart enough, what he will think that, sir, I need to put the value of X here. X will be having the unit of minutes, then alpha has to have the alpha will have the unit of 1 by minute only. Alpha will be having the unit of 1 by minute. So if I need 1 by minute, so what is given? 24 customer per hour, 24 customer per 60 minutes. That means 0.4 customer per minute. That's it. 0.4 customer per minute. 0.4 customer per minute. That's it. This is the value of alpha. Is it the expectation of X? No. Expectation of X is 60 by 24. But I am supposed to find out the value of alpha. So I need the value of alpha. I don't need expectation of X. I need expectation of X so that I can find the value of alpha. Because expectation of X is 1 by alpha. So from here I can get the value of alpha. Or if you can directly find out the value of alpha, then this is how you can find it out. 0.4 multiply with 1 by minute. Is that clear to you? Otherwise you can think you have written the random variable, then you find out the average time between two successive customer arrival. So it is given that 24 customers are arriving per hour. That means 24 customers are arriving in 60 minutes. That means one customer would arrive in 60 by 24 minutes. That means between two successive customers, the time would be 60 by 24 minutes. That means the expectation is coming out to be 60 by 24, which will be equals to 1 by alpha. So the value of alpha is coming out to be 0.4. This is the core concept. If you just want to play with the units, this is having a unit of minutes. This will have the unit of 1 by minute. That means, sir, I need to find something which is having a unit of 1 by minute. 24 customer per 60 minutes. Job done. 0.4 customer per minute. Job done here. That's it. Understandable? So let's find out the probability between 2 minutes to 5 minutes. Between 2 minutes to 5 minutes. Between 2 minutes to 5 minutes. Alpha is 0.4 e to the power minus 0.4x dot dx. 0.4 goes outside, e to the power minus 0.4x, 0.4 will also come outside, minus sign will come, and unit although the limit is going from 2 to 5, but I will do 5 to 2. Why is that so? Because another minus sign would come, no? So this minus sign I have taken inside. When you take minus sign inside, what happens? The limit interchanges. So answer is e to the power minus 0.8 minus e to the power 2. That's the answer. So e to the power minus 0.8 minus e to the power minus 2. So answer is 0.313. Approximate 0.313. Yeah, 0.3139. 0.3139. That's the answer. 0.3139. That's the answer. Okay. So similar kind of question has been asked in GATE examination. Okay. Let's just say this question is coming in the GATE examination. How will you solve? Ditto same question. Ditto same question. Nothing new is there. You should be able to solve it. If you are not able to solve it, then that means I am wasting the time. What is my random variable x? Time between two successive goals. Time between two successive goals. Two successive goals. What does that mean? If they are talking about time, what does that mean? That means, sir, they are surely talking about exponential random variable. So, sir, if they are talking about exponential random variable, what does that mean? Sir, my PDF will be alpha e to the power minus alpha x with x greater than or equals to 0. I need to find out the value of alpha. Now, sir, what I am supposed to find out? Probability such that wait time is between 3 minutes to 7 minutes. Right? Between 3 minutes to 7 minutes. That means, sir, I know the unit of 3 minutes. I know the unit of x. I know the unit of x. If you know the unit of x, between 3 minutes to 7 minutes, you need to put alpha e to the power minus alpha x dot dx. So, if you know the unit of minutes, then what will be the unit of alpha? The unit of alpha will be 1 by minute. Now, what is given? 18 calls per hour. Average 18 calls per 60 minutes. That means you are getting 18 by 60, what that would be? 0.3 calls per minute. 0.3 calls per minute. That will be the value of alpha. 0.3 will be the value of alpha. That means from 3 to 7, value of alpha will be 0.3 only. Why it is 0.3? I hope you would have understood. Because I need to find out the unit as 1 by minute. So not writing down the complete concept. What will be the complete concept? Sir, expectation of x would be average time taken between two successive calls. Now in 60 minutes you are getting 18 calls. That means in 1 minute you are getting 0.3 calls. Right? So what will be the time between two successive calls? What will be the time between two successive calls? The time between two successive calls will be 60 by 18. Right? The time between two successive calls will be 60 by 18. So expectation of x would come out to be 60 by 18. This will be the expectation of x. That would be equals to 1 by alpha. So from here the value of alpha will come out to be 80 by 60, which will be equals to 0.3. So this will be the actual concept. The expected time between two successive calls will be 60 by 18. Why is that so? Because in 60 minutes you are getting 18 calls. Right? That means one call you are getting in 60 by 18 minutes. So between two successive calls, how many time would be there? 60 by 18 minutes. And that will be equals to 1 by alpha. So value of alpha is 0.3. Otherwise, you can play with the unit. The unit of alpha will be 1 by minutes. So directly you can get 0.3 per minute. Minus 0.3 into x. You can solve the integration. The answer of integration would come out to be, this will be the answer of the integration. You can solve it on your own. Okay. So e to the power minus 0.9 minus 2.1 0.284. So answer is 0.284. That's the answer. Okay. Very simple question. And now you are completely comfortable with all the kind of problems. 0.284. Is that clear to you? So if the question is asked on exponential distribution, they may confuse you with the word of Poisson's distribution, but you will never get confused. You would know that if they are talking about the time, that means Poisson's. If they are talking about the time, that means exponential. If they are talking about the number, that means it is Poisson's. Understandable? Let's go to the next one. This is a gate PYQ only. Now we are going to solve gate questions only. This is a gate question. This is also a gate question. And this is not a gate question. This is a random question. Okay. So let's solve this gate question. X follows Poisson's distribution. Probability of x equals to 1 is given. That is equals to 2 by 3. Probability of x equals to 2. You need to find out the standard deviation of the distribution. What is the standard deviation? What is the variance? What is the variance? Variance is equals to lambda. So what will be the standard deviation? Standard deviation would be equals to under root lambda. Standard deviation is always positive. I hope you remember it. Standard deviation is always positive. Okay. Standard deviation is always positive. So standard deviation would be equals to root lambda. That's it. So this is what you are supposed to find out. Your answer is under root lambda. So probability of x taking value equals to 1. What is probability of x taking value equals to r? So that is nothing but e to the power minus lambda, lambda to the power r divided by r factorial. So probability of x taking value 1, e to the power minus lambda, lambda to the power 1 divided by 1 factorial would be equals to 2 by 3 e to the power minus lambda, lambda to the power 2 divided by 2 factorial. So this and this is getting cancelled out. Now 2 and 2 is getting cancelled out. So from here lambda equals to lambda square by 3, right? This getting cancelled out, 2 and 2 is getting cancelled out, 1 by 3 lambda square, lambda equals to lambda square by 3. Okay, so from here the value of lambda is coming out to be 3. Value of lambda is coming out to be 3. Average cannot be negative, no? Expectation of x cannot be negative. So average value is 3. So lambda is coming out to be 3. So what will be the standard deviation? Standard deviation would be under root 3. That's it. This is the answer. This is the answer. Okay, well and good. In the examination, I guess they asked about the variance, but here I am asking about the standard deviation. Just to let you know that standard deviation will be always positive. So answer will be under root 3. In the examination, they asked about the variance. So in the examination, answer was 3 only. So this would have been the answer in the examination. But here we are asking about standard deviation. Understandable? Let's go to the next question. Lifetime of a bulb is a random variable having probability density function alpha e to the power minus alpha t is given probability that the lifetime is between 100 hours to 200 hours. That's it. Okay, this is what we are supposed to find out, and lifetime t is given in hours only. So what will be the answer? Probability of random variable x taking value between 100 hours to 200 hours, right? So between 100 to 200 alpha e to the power minus alpha t dot dt. So answer will be in terms of alpha only, right? So if you integrate it, what answer you will be getting? If I integrate e to the power minus alpha t divided by alpha, negative sign would also come, but I will interchange the limit. So answer would come out to be e to the power minus 100 alpha minus e to the power minus 200 alpha. That's it. This is the answer. This is the answer that we are getting. Say yes or no. Understandable? This was a very straightforward question. This was also asked in GATE examination. Now the last question of this lecture. You need to solve this question. A very good question, but have some patience. It is completely based on Poisson's distribution. Why is that so? Because what you are supposed to find out, estimate the number of days on which no bicycle is rented. No bicycle is rented. So number of bicycle rented, right? You would have understood that you need to find out the number of days in which estimate the number of days in which no bicycle is rented. That means what I will find out? First I will find out probability that no bicycle is rented. No bicycle is rented. Right? Probability that no bicycle is rented. This is what I am supposed to find out. So what will be my random variable x? Number of bicycles rented. Number of bicycles rented. The number of customer requesting number of request made. So what I will do, I will assume my random variable as number of request made, number of bicycle rent request made. That means in a day. What does that mean? That means in a day how many requests are coming? Here all the requests will be heard. What does that mean? If there is one guy who is coming and he is saying that I need the bicycle, okay, he is requesting that he needs a bicycle, then we will be hearing his voice. We will rent him. It's not that he will come, we will say that we are having the bicycle and we will not rent it. Basically the guy is having 3 bicycles. A guy is having 3 bicycles. Okay, how would I make the cycles? This is how I am making the cycles. He is having 3 bicycles. He is having 3 bicycles. If some guy is coming and he is asking one guy has come, he is asking, can I rent a bicycle? He will say yes. Another guy is coming, he is asking, can I rent a bicycle? He will say yes. Another guy is coming, he is saying, he is asking, can I rent the bicycle? He will say yes. Now fourth guy has come. Now three guys has already come, no? So if three people has already come, then three bicycles are already rented. Now the fourth people, now let's just say if there is some fourth guy is also coming. If there is some fourth guy is also coming, will he get the bicycle? No, because three guys have already got the bicycle. No, three guys have already got the bicycle. So fourth guy will not be getting the bicycle. Understandable? Very straightforward thing, no? So fourth guy will not be getting the bicycle. So this is what they are saying. So number of requests made, what does that mean? What does that mean? Number of requests made would be equal to the number of a bicycle rented. Are you able to understand this point? If there is only one request, that means only one bicycle will be rented. If there is only two requests, that means only two bicycles will be rented. If there is three requests, that means three bicycles will be rented. If there are four requests, that means one request is unheard. Let me write it down. If there are one request, that means one bicycle will be rented. If there are two requests, then two bicycles will be rented. If there are three requests, then all three bicycles will be rented. Here I am writing down all three bicycles will be rented. Now in a day, if there are four requests, then one request is unheard. That means you cannot give him bicycle. If there are five requests, then two requests are unheard. Is that understandable to you? Are unheard. So I am talking about the number of requests made in a day. Number of bicycle rent requests made in a day. So how many number of requests are there? Poisson distribution with a mean of 2 requests per day. That means on an average you are renting 2 bicycles per day. What is the meaning of this line? That means on an average there are 2 requests per day. That means on an average you are renting 2 bicycles per day. 2 bicycles per day. Right? So either you can assume your random variable as number of bicycles rented, or you can assume your random variable as number of requests made. Both are the same thing. Okay, so what is the expectation of x? Expectation of x is 2 bicycles per day. Expectation of x is number of requests are 2. So what they are saying? Estimate the number of days on which no bicycle is rented. If no bicycle is rented, what does that mean? Number of requests are 0. Number of request, or let's write down on the next page. If no bicycle is rented, what does that mean? Number of request is 0. Number of request are 0. So what you are supposed to find out? You are supposed to find out such that random variable x, which is equals to the number of requests made in a day, that is equals to 0. So this is what you are supposed to find out, which will be equals to e to the power minus lambda to the power r divided by r factorial. So lambda value is 2. So value of r is 0 here. So 0 factorial is 1. Lambda to the power 0 will also be 1 only. So e to the power minus 2. So what is the answer? E to the power minus 2 will throw the answer as 0.135. So this is the scenario. That means probability that in a day no bicycle is rented is 0.135. So in 365 days, what will happen? Just multiply this with 365. Just multiply it with 365 days. So you have find out the probability. I told you, whenever they are asking how many days in 365 days, that means if they are asking how many days, so what you will do, first you will focus on the probability. So I have find out that probability that no bicycle is rented. This I have find out. So that came out to be 0.135. Now in this I have find out for per day. Everything is going per day. X is the number of variables, X is the number of requests made in a day. So everything is going per day. Now I simply multiply with 365. So I will get the number of days, the expected number of days where there is no bicycle rented. So I will simply multiply with 365. So I will get the answer 49.39. So there are roughly around 49.39 days, or you can say there will be 49.39 expected days. There will be expected 49.39 days, 49.39 days when no request is made or no bicycle is rented, or both are the same thing, no? Or no bicycle is rented. Is that understandable to you or not? Is that understandable to you or not? Okay, now let's see the second question. What they are asking: the number of days on which at least one customer is denied a bicycle because all bicycles are already rented. At least one customer is denied. What does that mean? That means the requests are more than 3, right? So what we are finding out? We are finding out probability that requests are more than 3. What is the meaning of request being more than 3? What is the meaning of this line? Requests are more than 3. What is the meaning of this line? If the request is more than 3, what does that mean? That means at least one customer will be denied. One customer request will be denied. Say yes or no. Here you need to think a lot. I know it is a very good question. It is a very good question. Here you need to think a lot. So what did you understand? If the requests are more than 3, then at least one customer request will be denied. Right? So what you are supposed to find out? You are supposed to find out such that probability of x should be greater than 3, which could be given as probability of x equals to 4, probability of x equals to 5 till infinity, which is not possible to find out. So what I will find out? 1 minus probability of x equals to 1, or request could be 0 as well, no? Probability of x equals to 0, x equals to 1, x equals to 2, and x equals to 3. This is what we will find out. So 1 minus e to the power minus lambda, lambda to the power 0 divided by 0 factorial, e to the power minus lambda, lambda to the power 1 divided by 1 factorial, e to the power minus lambda, lambda to the power 2 divided by 2 factorial, e to the power minus lambda, lambda to the power 3 divided by 3 factorial. So 1 minus e to the power minus lambda, 1 minus e to the power minus lambda, e to the power minus lambda. What is the value of lambda? Lambda value is 2. So e to the power minus lambda I am taking common. So what I am left with 1 plus lambda square by 2 plus lambda cube by 3. So 8 by 3 plus 4 plus 1 multiply with e to the power minus 2. ये क्या हो गया भाई? ये आंसर नेगेटिव क्यों आ रहा है यार? e to the power minus lambda, value of lambda is 2 only, no? Value of lambda is 2 only. So lambda square by 2, lambda cube by 3, 8 by 3. Okay, it was 3 factorial, no? It was 3 factorial, so this would have been 6. Right? E to the power minus lambda, lambda to the power 3 divided by 3 factorial. So 3 factorial is 6 actually. So 2 to the power 3 is 8 divided by 6. Right? Plus 5 into e to the power minus 2 minus 1. So probability is coming out to be 0.1428. Right? But this is coming out to be for 1 day. 1 day. But we need to see for 365 days. So 0.18 into 365 days. Multiply with 365 days. That means that will be 52.1499. These many days would be there. So that's the answer of the second question. Understandable? Okay. So 49 and 52 are the answers. 49 and 52. Is that understandable to you? Is this question understandable or not? So what is my random variable I am assuming? Number of requests made. Number of requests made, or you can say number of bicycles rented. Because if I am making one request, that means one bicycle will be rented. If I am making two requests, that means two bicycles will be rented. If I am making three requests, that means three bicycles will be rented. If I am making four requests, then one request is unheard. If I am making five requests, that means two requests are unheard. Right? Are you able to understand this point? So first question was no bicycle is rented. That means no request is made. So probability of x taking value 0. And what is the expectation of x? Average number of requests made in a day. So average number of requests made in a day is 2 requests per day. So that is equals to 2. Then we solved it. And then we multiply with 365 days. Because in a day there is a 0.135 probability that no request is made. So in 365 days, the probability is 49.39. Sorry, in 365 days, how many days would be there? 49 days would be there where there is no request. Second probability that requests are more than 3. So if the requests are more than 3, what does that mean? They are asking that at least one request is denied. That means request has to be more than 3. That means request could be 4, 5, 6. If request is 4, then one request is denied. If request is 5, then two requests are denied. Till infinity, that could be find out as 1 minus probability of x taking 0, 1, 2, 3. So this is how we find out, and that's the answer we are getting. Understandable? So this is done. Your probability distribution is completed. Now next topic we need to study about stats. Okay. So next what we are going to study? We are going to study statistics. Okay. So this is what we are going to study next. And that will be the last video. So here your probability, random variable and stats will be completed. So probability and random variable are already completed. This is the end of random variables. Everything we have studied, and next we need to study about stats. Okay. Yeah. Thank you very much. Happy learning. Let's meet in the next lecture.